Hi, welcome to the module Python for Data Science. I am Neeraj, your instructor for the module. Before we begin, let me tell you a few things about this module. This module is aimed at beginners in Python, so even people who are well versed in other programming languages such as Java but new to data science are expected to go through this module since the syntax may be different. We'll be learning basic Python in this module, which will be sufficient to get you started with data analytics. And as you will progress to the other modules, you will pick up some advanced Python skills. This module has been supplemented with lots of questions and hands-on exercises to make you comfortable with Python as much as possible. That is all good, but you must be thinking, why did we only choose Python and not R, Java or any other language for this module? Let me tell you why. Python is an open source language, so you do not need to worry about licensing fees or purchasing softwares for your analytics tasks. Coding in Python is similar to writing logic in English, and this is one of the reasons for its popularity. You don't have to write a large code just to print a statement. For example, a sample code to print hello world in C looks like this. Here we can see that we need to first import some input-output libraries, then create a main function, and finally print hello world. Java is no less. In order to print hello world in Java, you need to first create a class, define the main function, and then proceed with printing the hello world statement. But things are pretty much simple in Python. You can directly print hello world using the print method, and that is it. No hassle of creating a class or defining main function, etc. Python takes care of all that by itself. Another reason why we chose Python for this module is its very large and active developer community. So in case you are stuck somewhere, you will always find a solution with a simple Google search or by asking somebody. And because of this, there has been some awesome contributions to the Python packages repository, like scikit-learn for machine learning algorithms and Pandas for handling data, etc. I gave you reasons enough to be motivated to learn Python. Let's get started by installing Python first. I hope you must have installed Python in your systems by now. In this video, we will get familiar with some basics of Python language. First of all, let me brief you about the topics that we'll be covering in this Basics of Python module. The first topic that this video is about operators. In the later videos of this module, we'll be covering variables, different data types in Python, conditional statements like if-else, looping constructs like for loop, and functions. We will also see how the packages are structured in Python. And finally, we will get familiar with Pandas, a very efficient module for data handling in Python. So let's get started with our first topic, that is operators. So what are operators? In simplistic terms, operators are symbolic representations of mathematical tasks. Or in other way, this is how computers recognize what mathematical tasks to perform. Here are some mathematical tasks such as addition, subtraction, along with their symbols. For example, the operator of addition is plus, while the operator for the subtraction is minus. Similarly, for multiplication it is asterisk and division it is a slash sign. Let's see a simple operation of addition. It is represented as 3 plus 5, where 3 and 5 are called operands and plus is the operator which symbolizes addition. There are different kinds of operators. Let's look at different kinds of operators. Operators can be mainly divided into three categories. First, the arithmetic operators. Second, the conditional operators. And third, the logical operators. Let's see each of them in detail. Arithmetic operators help us in performing some arithmetic tasks, like addition of two operands, subtracting the second operand from the first, multiplying two operands, and dividing the first operand by the second. The output type of arithmetic operators depends on the operands. For example, here we have two numbers that are being added, so the output of this is a number. But for example, if we take a string and multiply it to a number, it returns to a string. Basically what it does is, in this particular operation, it returns the string this number of times. So the output is string, string, string. But what if we add a number to a string? In this case, it returns an error. So the return type depends on the operands. Now let's move on to the another type of operators, that is comparison operators. There are different kinds of comparison operators like less than operator, less than or equals to, greater than or equal to, and not equal to. So basically these comparison operators return an output based on one of these operators. So for example, what you can do is we can compare 3 and 5 and see whether 3 is less than 5. The thing to note about comparison operators is they always return true or false value. So for example, when we check 3 is less than 5, it will return true, and if we check whether 3 is greater than 5, it will return false. So this was all about comparison operators. Let's move to the last kind of operators, that is the logical operators. There are basically three kinds of logical operators: and, or, and not. Let's study about them in detail. Let's look at the formal definition of AND operator in Python. AND operator is defined as it returns the first false value, and if not found, it returns the last. I want you to pay attention on this because this is not the conventional definition of AND operator which you commonly hear. Let's first define what the conventional definition is. Generally, these logical operators are defined in context of logic gates, and they are used on the truth tables. So for example, a truth table looks like 0 0, 0 1, 1 0, and 1 1. In conventional definition, AND gate takes two input and returns true only if both the inputs are true. So in computer, 0 represents false and 1 represents true. Let's work through this exercise. So result of AND operator on the first one is 0 and 0. Since both are false, AND operator will return false. 0 and 1, in this case 2 AND operator will return false. For 1 and 0, AND operator will return false. 1 and 1, since both the inputs are true, AND operator will return true. So this is when the AND operator works in the conventional way. But what if we want to do something like 3 and 5? What is the output that you wish to accomplish? You must be tempted to say 1, since 3 and 5 are both true. But this is not the behavior that we often desire. So in Python, AND operator is implemented a bit differently. And this is how it is implemented in Python. Let's review it again. So AND operator takes two operands and returns the first false operand, and if not found, returns the last operand. So what do you expect in this case? So for example, AND operator goes through this value first, and since 3 is a true value, it moves to the second operand. Now it returns the last operand. And what about if we work on this logic gate? Let's see. Since the first operand is false, it returns the first operand. In this case too, the first operand is false, so it retains the first operand. Now, since the first operand is true in this case, AND operator moves to the second operand and returns it. In case of 1 and 1, the first operand is true, therefore AND operator moves to the second operand and returns it. You might notice that this is the same result as we got in the conventional logic gate. So I hope you had a good understanding of the AND operator. Now we'll move to the next operator in logical operators, that is the OR operator. Before wrapping up, let's have a look at some of the examples of AND operator. So for example, we want to check something like if 3 is less than 5 and also 5 is greater than 3. We can do something like as 0 and 3. Also we can do something like true and false. So these are some of the examples of logical AND operator. Let's move to the second operator in logical operators, that is the OR operator. So the definition of OR operator in Python is it returns the first true value, and if not found, it returns the last. Let's work this definition on our logic gates example. Now for 0 and 0, the first operand is false, so it will move to the last operand and return it. In the case of 1 and 0, so what OR operator will do is, since the first operand is true, it will return it. In case of 0 and 1, since first operand is false, it will move to the second operand and return it. In the case of 1 and 1, the first operand is true, therefore it returns it. So this is what is the output of the OR operator. Some examples of OR operator is whether we can check whether 3 is less than 5 or 5 is greater than 3. We can also do something like 0 or 3. or we can do something like true or false. Let's move to the last operator in logical operator, that is the not operator. Not operator flips the boolean value of the operand. Now what is the boolean value? Every value or number has an associated boolean value with it. So for example, 3 has a boolean value of true, 0 has a boolean value of false. Also, any string has a boolean value of true. This can be extended to anything. Only the 0 have a boolean value of false. Let's look at a few examples to understand this. So when applying the not operator on 0, since 0 represents false and not operator is supposed to flip the boolean value, the opposite of 0 or false is true. In the case of not 3, since 3 represents true, not true is false. Similarly, Neeraj represents true, not true is false. So care has to be taken that and or returns one of the operands, as we saw in this case, while the not operator returns only true or false. In this part of the video, we'll be implementing the topics that we studied in the previous video about the operators. So let's switch on to the Jupyter notebook. Here, this is the notebook that I have created where we'll be implementing all the concepts that we studied in our previous video. So first of all, we'll be implementing the arithmetic operators. So let me create a markdown first. So let's start with the very simple act of addition. That is, let us look at the addition operator. Like we studied, addition operator is symbolized by the plus sign. So let's try to add two numbers, that is 3 plus 5, and it gives an 8. We can also perform subtraction, where I can subtract 46 from 54, and again I've got 8. So the next operator in line is the multiplication operator. So we can multiply two numbers, like we can simply multiply 2 with 3 to gain 6. So multiplication operator is given by this asterisk sign, like the subtraction is symbolized by the minus sign. The last arithmetic operator that we'll be studying is division. So I can see whether 35 is divided by 7 and it returns 5. Also, we studied that the return type of these arithmetic operators depend on the type of the operands. So let's see that. So for example, what if I add my birth date to my name? So my birth date is 20. Let's see what happens. As you can see that it throws an error. Can't convert int object to string implicitly. So let's try to do this explicitly. What if I, instead of adding the number, I should convert that into a string? So like if I keep this 20 within the double quotes, let's see what happens. So it produces an output Neeraj 20. So in this case, the first operand was a string and the second operand was an integer, and it threw an error. Whereas in this case, the first operand was a string and the second was a string too, and the final result was a string. So in case the output depends on the type of operands you're dealing with in the case of arithmetic operators. But it's not always that using a string and an integer with arithmetic operators is going to give you an error. So for example, let's see this case. What if I multiply my name to an integer? That's a big one. Let's take it small. So what it did is it produced an output which is my name, the number of times this number. So Neeraj, 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 Neeraj. So it actually depends on the type of the operands that you're dealing with, the operator that you're dealing with. And as you practice more, the more better you get at, and you'll find the edge cases. Next, we'll move to the second kind of operators that is studied, that is the comparison operators. So let me create a markdown first. Okay. So the first comparison operator that we are going to do is to check whether a number is greater than the other one. So for example, I can check whether 45 is greater than 34 and it should return true. So like we discussed in the previous video, these comparison operators only return boolean values, that is true or false. So we can also check whether a particular number is less than the other or not. For example, I can check whether 56 is less than 23 and it should return false. So here we have taken simple constant values and compare these constant values. We can also take complex operand instead of a simple operand like a number. For example, I can do something like 34 multiplied by 34 again, and whether it is less than 45 multiplied by 23, and it will return you an output, and that is false in this case. You can also check whether two numbers are equal as a measure of comparison. So for example, I can check whether 45 is equal to 45. Just remember, in equal to we use a double equal to for comparing, and it returned true. So this was all about comparison operators. The last kind of operators that we are going to talk about are the logical operators. So let me create a mark one first. We studied three types of logical operators. The first one was the AND operator. We'll see a few examples of AND operator. So if you remember in the previous video what we said, in Python, AND operator takes two operand, let's say 0 and 3. It takes two operand and checks whether the first operand is false. If it is false, it returns the first operand, otherwise it returns the second operand. So in this case, 0 and 3, the first operand 0 is false, so this should return 0. But what if we do something like 3 and 0? Since the first operand here is not false, it will move to the second operand and return it, and it should return 0 in this case too. But what if we have something like 3 and 5? Let's walk through this again. The first operand is not false, therefore it moves to the second operand and returns it, so the answer should be 5. This was about the AND operators and their implementation in Python. Next, let's move to the second type of logical operators, that is the OR operator. So what OR operator does is, it takes two operand. Let's again take the above example, 0 or 3, and checks for the first true value, or in the other sense, it checks whether if the first operand is true, it returns it, otherwise it returns the last. But in this case, since the first operand is not true, it should return 3, and that is the answer. What if we write something as 3 or 0? So in this case, our first operand is true, so the OR operator should return 3, and that is true. What if we do something like 3 or 5? So in this case, since the first operand is true, it should return true. So this was about the logical operators that we studied. So now we have covered all the three kinds of operators that we studied in the previous video. The first is arithmetic operators, the second comparison operators, and third the logical operators. In the previous video, we learned about some operators like addition, subtraction, and less than, etc., and used them on constant values like 3, 5, true, nearest, etc. But you cannot always work with constants. Let me explain you why with the help of a scenario. Imagine you are working in a team of 6 people. Your friend noted down the salaries of all the people on the team and mailed it to you. He asked you to check if a female named Swati is earning significantly higher than the rest of the team. You open the mail and see some salaries. How should you verify whether Swati is earning higher or not when you do not know which of these numbers is Swati's salary? But it certainly would have been better had the mail contained the salaries along with the names of the people in the team. You may or may not have realized that you made use of names or variables to make your problem easier. So what are variables? Simply described, variables are names bounded to objects. Here, these arrows represent the variables, and these are the constant values or the objects. Now since we know what variables are, how are these variables used in Python? Variables are first assigned a value and then it can be used in Python. So the general syntax is, first comes the variable name, then the equal to sign, which is also called the assignment operator, and then the constant value to be assigned to variable. For example, a equal to 5 is a variable assignment operation, where a is the variable and 5 is the value. Now that you know how variables are assigned in Python, it is better to know how variables are stored and how do they work in Python. Have a look at this assignment operation. So for example, when you do something like I equal to 5, Python first identifies the type of the constant value. Since it is an integer, it creates an int object in the physical memory, store 5s in it, creates a variable called I, and binds this variable to this memory location or the object. Now when you do something like j equal to I, such as this, so what basically it does is it binds j to the same location to which I is bound to, that is this int object. Now when you do something like j equal to 3, what it does is it creates another object, int object, puts a value of 3 in it, removes this pointer from here and makes it point to this new location. So when you print I, so still I is pointing to this object. So in this case, it will print I as 5. So this is how variables work in Python. Now that you know what variables are and how do they work in Python, the next step is to see the rules which need to be followed while creating a variable. Let's see them one by one. First, Python is case sensitive. Therefore, a equal to 5 and a equal to 5. The first one is a capitalized one and the second one is a smaller one are different. Second, variable names cannot start with special characters except underscore. So because of this, underscore sam equal to 5 is a valid variable name, but at the rate sam equal to 5 is invalid. Also, variable name cannot start with a number. So something like 9 sam equal to 5 is invalid. Now, a name once chosen, a variable can be used to store different types of data. So for example, a variable can contain an int data, that is the integers numbers, for example 4, minus 5, etc. Variables can also store decimal type numbers using the float data type. So they can store numbers like 4.5, negative 6.7, etc. Bool data type facilitates storage of the Boolean values, that is the true and false. We can use the str data type to store strings, such as Python in this case. So in this video, we'll be implementing the concepts that we studied in the previous video. So first of all, we'll have a look at the variable assignment. So first of all, let me create a markdown. So like we discussed in the previous video, a variable assignment starts with a variable name. Let's say I take a simple variable such as a, then it takes an equal to operator and then the value. So for example, if you want to assign the value of 5 to a, so I can do something like a equal to 5 and a will have the value of 5. So how do we check it? So let's print a and we can see that a contains the value of 5. Now we also discussed that Python is case sensitive. So for example, if I do something like a equal to 4, so this in no way will affect the small a variable. We can still check that. Let's print both of these. As you can see, the a1, the small a1 still has a value of 5 while the capital A has a value of 4. So this was about how we can assign variables in Python. Next is how do variables work in Python. So for example, let's see at these variable assignments. So for example, a equal to 7, then let's say b equal to a, and now we change the value of a to 3. So what do you think should be the value when we print a? It's 3. And the value of b? It's 7. So how did this happen? So for example, when we did something like a equal to 7, so what Python did was it created an int object, put 7 in that and made a point to this object. Now when we did something like b equal to a, so b starts pointing to this object. But when we do something like a equal to 3, so Python builds an object like 3 and removes the pointer from the 7 and starts pointing towards 3. So when you print b, so what it does is, since b is still pointing to the 7, the value of b changes to, the remains same to 7, whereas the value of a changes to 3. So this is how variables work inside Python. Now let's look at some of the rules for variable name declaration. So for example, first of all, let me create a markdown. So this is a simple variable assignment and there should be no problem with that. But we studied that a variable name cannot start with any special character other than an underscore. So for example, let's create a variable with an underscore. So a equal to 5 should work, but any other special character like @ should produce an error, and there is it. Also, we studied that variable name cannot start with any number. So if I do something like 1a equal to 5, this is also going to produce an error. Now the next topic in line is the data types in Python. So like we discussed in the previous video, so there are generally 4 data types in Python, but we do not explicitly write down the data types of variables. Python automatically identifies these data types. So for example, when you do something like a equal to 5, Python automatically identifies that this is an integer type variable and it allocates an object accordingly. But what if we need to find the data type of an object or a variable? So for example, if I do something like a equal to 5 and I wish to find what is the data type of this variable, I can do something like type and the name of the variable I wish to find, a. So it returns the type of the variable that I'm dealing with. Similarly, if I do something like p equal to image and use the type function on the p, it returns that I'm using the string type variable. So this was all about the variables and data types in Python. In the next video, we'll be talking about conditional statements in Python. Many of the times, our decisions are based on some form of condition. For example, if you arrive late at home from work, then you are going to order the food. Otherwise, if you happen to make it on time, then you are going to cook food for yourself. This example best describes when you make decisions based on a condition. And more often than not, data analysts also make decisions based on a set of conditions. These conditions are implemented in Python through the if-else statements. Let's see the syntax for the if-else statement in Python. We can see that the syntax itself is quite simple. It has two keywords, the if and the else. The if keyword is followed by the condition that we want to check, followed by a colon sign, and then the statement that we want to be executed in case the condition turns out to be true. If the condition is not true, this statement too gets executed, which resides inside the else block. Care has to be taken that there is an indentation or space in the statement after the if condition. So this is the space that we are talking about. It is very important in Python since Python does not follow curly brackets like other languages for defining the scope visibility. Let's convert our previous problem into the if-else statements. So for example, our condition was that if we turn out to be late, we want our food to be ordered. Otherwise, if we are not late, we want our food to be cooked. So this food to be cooked resides inside the else statement, and the condition that if we are late is checked inside the if condition. If else condition is good when we want to check a single condition, but what if we want to check multiple conditions? For the multiple conditions, we have the if, elif, else statements. The syntax for the elif, else statement is very much similar to the previous one. The only addition is this elif statement, which contains provision for checking of extra condition. So what we can do is we can check a particular condition in the if block, execute a statement corresponding to this condition. If this condition turns out to be false, we can check for another condition in the elif block and execute the statement corresponding to this condition. If every condition is false, then this statement is executed. Let's look at this problem. Assume that we have a variable x and we want to print positive if x is greater than 0, print 0 if x is equal to 0, and negative if x is less than 0. So how can we convert this problem statement into a if elif else statement? Let's see. So how I did this is, first I want to check if x is greater than 0. So this block over here checks whether if x is greater than 0, and if yes, it will print a positive statement. But I also want to print 0 if x is equal to 0. So I'll put this x equal to 0 in the elif statement. But keep in mind that we will use a double equal to compare rather than a single equal to. Single equal to is for assignment, while double equal to is for comparison. And we want to check value of x with 0. So this is a comparison task. So if x is equal to 0, we want to print 0. And if x is neither greater than 0 nor equal to 0, we want to print negative. So this statement falls under the else block. So this is how we can convert this statement using the if, elif, else statement. In the previous video, we studied about various conditional statements, particularly if-else statement and if-elif-else statement. In this video, we'll be implementing these statements in Jupyter Notebook. So for the purpose of implementation, we have two problems. Problem 1, where we take a variable x and print even if the number is divisible by 2, otherwise print odd. So we'll be solving this problem first using the if-else statement. We have our initial condition with us. If the number is divisible by 2, we want even to be printed. Otherwise, we want to print odd. So let's create a skeleton of if-else statement first. So if the number is divisible by 2. So I'm not writing the condition as of now. The colon, enter. Python automatically indents for you. So what do we want is to print even. Next, if the number is not divisible by 2, what we want to print is odd. So this is what basically this statement looks like when converted into a if-else statement. Now we just need to write the code for if the number is divisible by 2. So for that, what we can do is we can make use of the mod operator. The mod operator gives you the remainder. So when we write something like x mod 2, it is the remainder that we get when x is divided by 2. If x is completely divisible by 2, it will give a remainder of 0. So this is how our if-else statement looks after we specified the condition. So now let's check this. Suppose the value of x is 3. We run this block and we get odd. What if the value of x is 5? That is odd too. Now, and what if the value of x is 4? We get even. Now let's move to the problem number 2. We'll be solving this problem using the if-elif-else statement. So problem 2 states that take a variable y and print grade A if y is greater than 90, grade B if y is greater than 60 but less than or equal to 90, and grade F otherwise. So here we can see that our first condition is if y is greater than 90, our next condition is if y is greater than 60 but less than or equal to 90, and if both these conditions are false, we want grade F to be printed. Let's convert this into if-elif-else statement. So if the condition colon enter, what do we want is we want to print grade A. Now if y is not greater than 90 but greater than 60, so what do we want is now we want this condition to appear in the elif statement. So I'm not writing the conditions as of now. Elif print grade B, and if both these conditions turn out to be false, we want to print now. So our first condition is if y is greater than 90. So if y is greater than 90, we want to print grade A like this over here. Now if y is greater than 60 but less than or equal to 90, we want grade B to be printed. So the elif statement takes care of the value of y doesn't reach above 90. So in case it reaches above 90, this statement is going to be executed rather than this. Although we can write something like and y is less than or equal to 90. This is also correct, but automatically Python takes care of that. For now, let's continue doing this. Otherwise, we want the grade F to be printed. So let's check this for value of y equal to 56. It prints grade F since 56 is less than 60. What if y is 90? It's grade B. That's good. What if it is 98? It's grade A. Now let me show you how removing this won't affect our result. So again, let me start with 56. So if y is 56, the grade is F, and if I do something like y is equal to 98, I still get A and not B. Since this statement is being executed first, when this statement gets executed, the transfer of statement falls back to the end. So this elif and else statement do not get executed. Similarly, for something like 90, we get grade B as the answer. So this was how we can implement if, else, if, elif, else statement in Python. Many a times, we often wish to repeat a particular task. So for example, we wish to print Python is awesome 1000 times. Should we write the print command 1000 times? As it turns out, no. Python provides looping constructs to help repeat a task. We will be talking about a particular looping construct called for loop. A sample for loop in Python looks like this. So you might notice this is quite a different syntax than the for loop in other languages. So for example, for loop in Java looks like this, where a variable is initialized first, then there is a condition followed by the increment operator or the decrement, whatever be the case. Then here comes the statement. So how a particular loop goes is, first the variable is initialized, then the condition is checked, the statements are executed, then the value of the variable is updated, again the condition is checked, and this loop goes on and on again till this condition turns out to be false. But this is not how for loop work in Python. For loop requires iterables. So what are iterables? For example, in this case, for I in range 1000, what range 1000 does is, it creates a sequence which starts from 0 and ends at 999. So what for loop does is, for loop picks each of these values in the sequence and executes this statement. So first for loop picks this 0, executes Python is awesome, then it picks 1, executes Python is awesome, 2, and so on till it reaches the end of the sequence. So this is how for loops work in Python. In this video, we'll be implementing the for loop that we studied about in the previous video. So we have two problems that we'll be solving using for loops. The first problem is, we need to write a for loop to print all the numbers between 10 and 50. Like we studied in the previous video, what for loop is going to do is, it needs an iterable. So we are going to prepare an iterable that is going to have all the numbers between 10 and 50. Let's take a variable I in range. Since we need numbers between 10 and 50, so it would not include 10. And as you saw in the previous video, we need to start this first value with the number that is going to be contained. So range 11 comma 50. So when we write something like 11 comma 50, what it will do is, it will create a sequence that will start from 11 and at 49, a colon and a print statement to print all these numbers. Let's run this. So here we can see that we have printed numbers which are starting from 11, 12, 13, 14 up till 49. So this was a relatively very simple problem. Now let's look at the next problem, where we need to write a for loop to print all the odd numbers between 10 and 50. Now there are multiple methods by which this problem can be solved using a for loop, but the one that I am going to use in this is important because it will tell us something more about the range function that we have been using. Let me just first solve this problem. So for I in range 11 comma 50 comma 2 colon and print I. Here we can see that it is 11, 13, 15, 17, 19. So an increment of 2. So now let me tell you about what is this new addition to the range function. When we write something as range a comma b, it creates a sequence that starts from a and increases 1 until it reaches b minus 1. Okay, so b is not included, but a is included. But when we write a third parameter, that is a comma b comma c, so what it does is, it creates a sequence that starts with a, it increases a by c times, so next is a plus c, the next one will be a plus 2c, it goes on till it reaches b minus 1. So this is how range functions. So here what it has done is, so it starts with 11, then 13, then 15, 17 and so on till it reaches 49, and we have just printed these values. So this is how for loop is implemented in Python. In this video, we are going to talk about functions, which help us in performing the same type of task, for example like printing. Printing Python is awesome and I am awesome are two different statements, but same type of statements. Both are print statements, but print two entirely different statements. While printing Python is awesome 1000 times is done via loops, printing in general is handled by functions. So, what is a function? Function is a reusable piece of code created to solve a specific type of problem, like printing any statement we saw earlier. Functions are of two types. First, the built-in functions provided by Python, like the print statement we commonly use. Range function that we saw in the loops, min, max, etc. The second type of functions are user-defined functions that we can create to solve our problem, for example like function to calculate area of any circle. Let's see how we can define a function in Python. A function is defined by a def keyword followed by the function name and arguments enclosed in the brackets. This is followed by a colon and some indented statements with a return statement at the end. A return statement is what exits the function. It may or may not return anything. So for example, let's create a function to calculate the area of a circle given a radius. Since we want to calculate area of the circle for any radius, we will keep radius as a user passed argument. So this is how we can create a function. The name of our function is area circle with radius as the argument, then followed by the formula to calculate area of circle and then returning this area using return statement. Now let's see how we can use this function to calculate the area for these two different circles. We can just call the function by using its function name followed by 1 as an argument for the smaller circle and 3 for the larger one. This is how we call the functions. Also, we can call functions anywhere in our entire code. This was all about functions. In this part of the video, we'll be implementing functions that we studied about in the previous video. We'll be solving this problem for functions where we need to create a function that takes two numbers as argument and returns the greater of the two. So let's get started. As we discussed in the previous video, we define a function by the def keyword. So we use the def keyword. Let's name our function compare. This function takes two numbers as argument. Let us define these numbers as a and b followed by a colon sign and then enter. So we need to return the greater of the two. So I can use an if statement such as if a is greater than b, what I can do is make another variable greater and assign the value of a to it, since according to this condition a is greater than b. If a is not greater than b, automatically b becomes greater. So we can assign b to the greater variable. Now when a comparison is done, we wish to return the value which is greater, but the greater value resides inside the greater variable, so we will be returning greater. So this is how we create a function. Let's see if this performs good. Let's call the function and input two numbers 10, 50 and return 50. Let's rerun it again with two different numbers, compare 14 with 5 and return 14. So this is how we implement functions in Python. Again, the care has to be taken that these statements are indented, so there is a space in between, and this is very essential for Python. Like I told you earlier, Python does not have curly brackets for scope visibility, and it uses these indentations to segregate the code. So this was all about implementation of functions. In the previous videos, we had a look at existing data types supported by Python, like int, float, bool and str. But they do suffer from some flaws. Let us look at the problems with existing data types. Variables of these existing data types can store only a single format. For example, integers for the int data type, decimal numbers for the float data type, true or false for the boolean data type, and only strings for the str data type. But sometimes it is required to have a mix of different formats of data, like storing personal information of a person. For a person, we might want to store his name, which is a string data type. We might want to store his weight, which is a float data type. We also might want to store the number of family members, which is an int data type. We want all these information to be at a single place. But if we want that, we cannot do this with the help of the variables. Now, since a variable of the existing data type can only store a single value, therefore, there will be a large memory overhead if you wish to store copious amount of data in variables. So for example, if you want to store the information of a family in variables, then the number of variables might be small, say like 5 or 6. But what if you want to store the information of the entire town? The number of variables might go to 100, 200, even it may run into thousands of variables, which will slow down the computation process and create a large memory overhead. Also, there is absence of inherent structure in variable. For example, if you wish to store some data as a sequence, then variables are not suited for this task. So, to address the above problem, let me introduce you to two data structures in Python. First is the list and second is the dictionary. A list can store mixed type of data in a sequential structure, whereas a dictionary can also store mixed data type, but it is unordered. That is, there is no sequence to it. For example, here 1 comes before Python, Python comes before 2, 2 comes before S. But there is no sequence between Ramesh, Sudesh and Suresh. We will discuss about each of them detail in the later videos. Before we begin, let's imagine a scenario. We are required to store marks of all the students in class 10th roll number wise. One way to solve this problem is to use variables for all the students and store their marks. But this is not a very good method to solve our problem. Let's see why. The number of variables become very large as the number of students in class increase. This can lead to a large memory overhead. Also, we won't be able to answer some questions like what is the average marks of last 5 students, or what is the marks of the student who is 3 roll numbers after 45. We cannot answer these questions since variables inherently do not support sequence, and we need a data structure that can handle sequences to answer questions like 2 and 3. This is where list comes in. In this video, we'll be talking about list. Let's have a look at the topics that we'll be covering about lists in this video. First, we'll see what is a list along with some examples. Next, we'll see how we can access elements of a list. This is also called subsetting. We'll also see how we can add elements to a list and delete elements from a list. Finally, we'll see how we can loop over a list to access its elements. Let's go ahead and discuss each of them in detail. So, what is a list? A list is an ordered data structure where elements are separated by commas and enclosed in a square bracket. So for example, list 1 and list 2 are examples of list, which contains a single type of data. List 1 has integers, while list 2 has strings. List can also store mixed data type, as in this list, list 3. Let's move to the next section where we will see how we can access the elements of a list, or as it is called, subsetting. Before we subset a list, let's first see how list elements are stored in a list. Take an example of this list, list 3. Its elements are stored using indexes, which start from 0. So, 1 is stored at index 0, Python is stored at index 1, 2 is stored at index 2, is stored at index 3, and so on. If we wish to extract a single element of a list, say at index 1, we can use the square brackets along with the index number like this. So, list 3 bracket 1 will return the element which is present at index 1. In this case, it is Python. So, this command returns Python as its output. So, this was how we can extract a single element from a list. What if we want to extract a sequence out of the list? We can extract a sequence out of the list using this format, where we have two numbers within the square brackets separated by colon. Let me explain you how this works. So for example, when I do something like list 3, 1 colon 4, so the list starts with this index, that is 1, and extracts the element till it reaches one index before the given over here. So for example, list starts from 1 and stops at 3. It doesn't include 4, that is this number. So for example, if you do something like 2 colon 5, so the list will extract the element from 2 and go up till 4. So from here till here. but it will not include this number. So this is how you can extract a sequence of elements. We can also extract the elements of a list from the end of the list using negative indices. So for example, if you want to extract this last element, I can use like list 3 minus 1 to extract the last element, and it will return awesome. So this was all about extracting elements from a list. Now let's see how we can add elements to an existing list. This is the list that we'll be using for this exercise. A single element can be added using the append function. So for example, if I do list 3.append 4, so this 4 will be appended to this list at the back. So when I print list 3, 4 is going to be present at the end of the list. We can also add multiple elements to a list. For adding multiple elements, instead of the append function, we'll be using the extend function. Care has to be taken that extend function takes list as its input. In comparison to append takes just a number as an input, whereas extend takes a list as an input. Now when you do something like list 3.extend 5, 6, what it will do is it will extract each element out of this list and add to list 3. So first it will extract 5, add it to list 3, here it will come, then it will extract 6 and add it to this list 3 after 5. So this is how you can add multiple elements to a list. You can also add list to a list. So for example, in the append function, if we pass on a list, this entire list will be appended to this list as an element. So for example, since 1 is at 0 index, Python at 1, similarly 2, 3, 4, 5. So when you do something like list 3.append 7, 8 in a list, and when you print list 3, this 7, 8 resides at the 6th index. So when you do something like, for example, list 3, 6, you're going to get a list as an output. So this was how you can add list to a list, and we have covered how to add elements to an existing list. Now, what if you want to delete elements of a list? There are two ways by which we can remove an element from a list. The first method is when we want to remove element by its value. So when we want to remove an element by its value, we can use the remove function and the element which we want to remove. So for example, there is 2 present in this list, and if we need to remove 2 from this list, I can do something like list 3 dot remove 2, and when I print the list, there will be no 2 present in the list. So it is now 1, Python is 3, awesome. The second method is when we wish to remove an element from a list using its index. So when I wish to remove an element using index, we'll use the del keyword. So for example, I want to remove the element present at index 3. So at index 3 is the element which is present. So when I do something like del list 3, 3, this element is going to be removed. So when I print list 3, it is 1, Python 2, 3 and awesome. There is no is present in the list. The last topic is how do we loop over a list or access each element iteratively for doing some task, such as printing the elements of a list. Here is an example how we can use a for loop to iterate over a list and print the statements. So like if you remember in the previous video of the loops, we talked about for needs an iterable, that is a sequence, and we just discussed that a list is a sequence. So what for loop will do here is it will extract each element from this list and print it. So for example, first 1 is going to be extracted and it will be printed, then Python, then 2, then is, then 3 and then awesome. This is how we can get access to each element in a list using a for loop. In this video, we'll be implementing all the concepts that we studied in the previous video about list. So let's get started. So first of all, let's see how we can create a list. Creating a list is very simple. We can just use the square brackets to create a list. So for example, like if you want to store the marks of the students in a list, let's call the list marks and let me store marks of 10 students in the list. So once we have created the list, we can see it as by printing it simply. So here we can see that the marks of the 10 students are present in the list called marks. So for example, If you need to print the marks of the student at index 5, for example, okay, so we can do that simply by marks bracket index 5, and it will print the mark 6. So the result is 6 because the index in Python starts at 0. So 0, 1, 2, 3, 4, 5, and hence 6 is the output. For example, if you want to extract a sequence like we discussed in the previous video, what I can do is marks. Suppose we want to extract all the marks from index 0, that is, to, for example, index 5. If you want to extract element at index 5, I'll write it as index 6. And when I do that, so I can see that at 5, 0, 1, 2, 3, 4, 5, 6 is the element. So it has returned all the elements from index 0 to index 5. Care has to be taken that the last index is not included in the output. Now, what if you want to add an element to this list? So adding an element is very simple. Like we discussed in the previous video, I can use the append function. So for example, I want to include one more marks. So I can do something like marks dot append, and I can add a marks 11. Now when I print marks, so 11 marks is going to be appended to the end of the list. Now what if you want to add multiple marks? For example, 2 more students marks we need to include in this list. So what I can do is I can use the extend function. So like we discussed, extend function takes a list as its input. So for example, I need to add 2 more marks. I'll include that in the square brackets to make it a list. And when I run that and when I print the marks, so 12 and 13 will be included as single elements in the marks list. Now what if you want to add a list to a list? For example, a list of 2 students. For example, I want to add marks of 14 and 15 to this list. So when I do the append and pass on to it a list, so what it will do is it will append a list rather than the individual elements. So when I print it, what it will do is it will append a list rather than individual elements. So this was how we added elements to a list. What if I wish to delete elements in a list? So deleting elements is pretty simple. So if you want to delete an element by value like we discussed, so I can just use the remove function. For example, I'm not interested in having this in my list. So what I can do is I can write it as marks dot remove and the element that we wish to remove. So for example, 14 comma 15. So this should remove this element from our list. When I print marks, I'll see that this list is no more present in our original marks list. What if we want to remove an element at particular index? Say suppose I want to remove this one which is present at index 0. So I can use the del keyword, then the name of the list and the index from which the element is to be removed. Since one is present at 0, so I'll write it as 0 index. When I do that, so this element will be removed from our list. When I print marks, so now 1 is no more present in the list. The list now starts from 2, 3, 4, 5, 6 and so on up till 13. So this was how we can delete elements from a list. Now the last thing that we want to implement in list is how we can access each element of a list. So for example, we want to print all the marks in the list. So I can do something like we can use a for loop to access the elements in a list like we discussed. So I can do something like for mark and marks. Since marks contain the list which is a sequence and for loop requires a sequence or iterable, so this is okay. For mark and marks, what I would wish to do is print all the marks. Print mark. So what it will do is it will first extract 2, print it, then mark will have a value of 3, then it will be printed, then mark will have a value of 4 and it will be printed and so on till it reaches the end. Let's see the result. So 2, 3, 4, 5, 6, 7, 8, 9 up till 13. So this is how you can access list elements. So instead of printing, you can perform your own operation, whatever you want to do with a list element. So for example, if you want to add 1 to each element, you can do that by this. So for example, if first you'll access the element and you want to print by adding 1. So you can do something like mark plus 1 and print it. So since the first element was 2, we have added 1, it becomes 3 and so on till the last element 13 becomes 14. So this was how you can perform operations in list. So first we saw how we can access elements. Before that, we saw how we can create a list, how we can access the elements by single element, multiple elements. Then we saw how we can add element to a list. Then we saw how we can remove elements from a list, and then how we can access each list using a for loop. So this was all about implementation of list. Before we start, let us have a look at this scenario. Suppose you have stored the marks of your friend Sam in this list. Now, can you tell how much did he score in history or in geography? No, you cannot, until you have the data where you have stored which subject marks are stored at which index. If we have this data, we can easily answer that since history is stored at index 1, we can say that Sam scored 36 marks in history. But there are a few problems with this approach. Many a times, this data is not available or very hard to create. Second, sometimes we do not want our data to have a sequence. For example, in the previous example, it does not matter whether history marks are stored after geography or before it. Also often, we want our data to be accessed by names. For example, like finding the history marks using the history word and not index. All of these questions can be answered using Python's another data structure called dictionary. So this is how dictionary is going to solve our problem. Instead of indexes, marks are stored using names or keys as we call them in dictionaries. So geography, history, mathematics, physics and chemistry are the keys, and 45, 36, 54, 78 and 44 are the values corresponding to these keys. Now that we know how dictionary can help us solve our problem, let's see what are the topics that we are going to cover about dictionary. First, we are going to discuss what a dictionary is. Second, we'll see how we can access elements of a dictionary. Then we will discuss how we can add elements to a dictionary and remove elements from a dictionary. Let's discuss about each of these topics in detail. So, what is a dictionary? A dictionary is an unordered data structure where elements are stored as key value pair. The key value pair is separated by colon, while the elements are separated by comma. The entire dictionary is enclosed within curly brackets. This is one example of a dictionary where value is a number. So, in this dictionary, Ramesh is the key and 150 is its value. Similarly, Suresh is the key and 146 is its corresponding value. You can also have other data types in place of numbers in the values. For example, this is another dictionary where value is a list. So for this key Ramesh, the values is this list of two numbers, which is 150 and 46. Now let's see how we can access elements of a dictionary. Elements in a dictionary are accessed by keys rather than index. So let's see what happens when we try to access this dictionary, that is dict2, using index rather than keys. So when we access this dictionary using index, we get an error because this is not how elements are stored inside dictionaries. Instead, the elements are stored using keys. So if you want to access details of Suresh, we can do something like dict2, the name of the dictionary, then the square brackets, and the name of the key whose value we want. So when we do something like dict2 Suresh, it returns its value, which is a list of two numbers, 146 and 58. Now let's move on to how we can add elements to a dictionary. Let us try and add a single element to a dictionary first. So this is the dictionary that we'll be working on. To add a single element, we can do something like dict2, the name of the key that we want and the value that we want to add. So operations such as dict2 Neeraj equal to a list of two numbers 176 and 75 will add this value and this key to the existing dictionary. So when we print dict2, we can see that there is an entry named Neeraj that is added to the dictionary. Now what if we want to add multiple elements to a dictionary? We can also add multiple elements to a dictionary using the update function. So this update function takes a dictionary as an input. So for example, I can add two key value pairs, first Sunil and Disha, to this existing dictionary using the update function. And when I do so, these two values, Sunil and Disha get added to the dictionary. This was all about how we can add elements to a dictionary. Now, what if we want to delete elements from a dictionary? This is the dictionary that we'll be working on. Deleting an element in a dictionary is very much similar to that of a list. But here, instead of the index, we pass in the key that we want to delete from the dictionary. So for example, if I want to delete the details of Ramesh, I can do something like delete, that is del, dict2 and Ramesh. So it will delete the Ramesh key value pair from the dictionary. So now our dictionary looks like this, where it has Suresh and Sudesh details. So this was all about dictionaries. In the previous video, we studied what a dictionary is and various operations like creating a dictionary, accessing elements of a dictionary, adding an element and deleting an element. In this video, we'll be implementing those discussions in Jupyter Notebook. So first of all, let us start with creating a dictionary. Let us create a dictionary of marks where we can store marks of different subjects. Like we discussed in the previous video, a dictionary is defined by these curly brackets and it has a key value pair where in this case key will be the subject and value will be the marks. So for example, in history we get 45 marks, in geography we get 54 marks and in Hindi we get 56 marks. So this is the dictionary of marks that we just created. Let's try to print this dictionary. So we can see that this is the dictionary that we created above. Now let's move to the first section where we can access elements of a dictionary. Accessing elements of a dictionary is very easy. We can access elements of a dictionary using the key that we have used in a dictionary. So for example, if I want to fetch the value related to the geography key, I can do something like marks and the key. So it will give us the value associated with this key, that is 54. Now, what if we want to add an element to this dictionary? Adding an element to this dictionary is very easy. So first of all, let's see how we can add a single element to this dictionary. Adding a single element is easy. First of all, marks, the key that you want. Suppose you want to add English marks to this dictionary. We can do something like marks, English, and suppose I scored 47 marks. Now, if you print our dictionary, English marks are added to this dictionary. What if I want to add multiple subject marks? So I can do this by using the update function that we studied. So this update function takes a dictionary. Suppose I want to add chemistry marks and let's say I scored 89 in chemistry and also physics marks, and let's say I scored 98 in physics. So now when we check the marks dictionary, we can see that chemistry and physics are stored inside this dictionary, which is the marks dictionary. Now, what if we want to delete an element in the dictionary? So it is very much easy. For example, I do not need Hindi marks in my dictionary. So I can delete that by using the del keyword, del marks, and then the key of the marks that I want to delete. So for example, I want to delete Hindi, and when I do something like, oh, there is an error, we stored Hindi within capital H. So this is a good point to remember that Python is very case sensitive. So small h Hindi and capital H Hindi are treated differently. So when I do something like this, and now when I print marks, so Hindi marks are removed from this dictionary. So this is how operations are done in Jupyter Notebook for the dictionaries. In the next video, we'll be studying about Python modules, standard library, and packages. In this video, we will talk about three very important topics. First, we are going to talk about standard library. Then, we are going to talk about modules. And at last, we are going to cover packages in Python. But before we start, why do we need to discuss these topics in the first place? Let me tell you why. First, having a knowledge of these topics can help us efficiently use the functions what others have created. This would save us the time of creating our own functions for the already solved problems. Second, having a proper structure helps when we wish to create our own Python packages, for examples like Pandas, sklearn, etc. But before we start, let us have a look at an example which will help us to have a deeper understanding of standard library and modules. And then we will eventually move on to their formal definitions. Every person has some skills which are either innate or developed over time. For example, I can play good football, I am good with computers, I can dance a bit, and sometimes I can sing too. But I am really bad at plumbing tasks like fixing kitchen, etc. I'm also pretty useless when the matter is of electricity, house cleaning, or financial services. For all these tasks, I prefer using services of others who are good at these tasks. Similar is the concept of standard library. Standard library is a set of skills that Python has by default, whereas when it needs to perform some other task which it is not good at, it relies on modules developed by others. I hope this was a good example. Let's get into the formal details of standard library, module, and packages. First topic that we'll be discussing is standard library. A standard library is a collection of code that you get when you install Python into your systems. Some examples of things included in standard library are built-in functions like print, max, min, etc. Built-in constants like false, true, none, etc. Data types native to Python such as int, float, bool, and str. Different file formats that Python supports reading and writing. There are many other types of codes too, like code to handle internet connections, etc. To use these functions, you do not need to import anything. You can use them on the fly. So this was all about standard library. Let's move on to the next topic, that is module. What is a module in Python? Have a look at this example. Do you remember the type of operators that we discussed in the previous video? This is one of those operators called the arithmetic operators. Here what I have done is these addition, subtraction, multiplication and division, which are the different types of operators for the arithmetic operator, have been given their own separate functions. So addition operator has become a separate function called addition. Similarly for subtraction, multiplication and division. These all functions reside inside a Python file which is called arithmetic.py. So this file is called a module. Similarly, we can create module for the logical operators too, where the different types of logical operators are the functions, and all these functions are included in a file called logical.py, which is again a module. Now since we know about modules, let's move on to the last topic called packages. Packages are nothing but the collection of modules. It is very similar to the folders we have on our computers. So let's extend the previous example of modules. I can take arithmetic module, logical and comparison module and put them in a folder called operator. The operator folder then becomes a package. Now, since you have knowledge about standard library, modules and packages, let's understand with the help of an example. Suppose you have two modules, a.py and b.py. A.py is what ships with the standard library and b.py is created by some Python user. You want to perform a subtraction task but want to use the subtraction function created by the Python user instead of the standard library. So how do you solve this problem? This is solved by importing the b.py module and using its subtraction. This way Python would know that it needs to execute the subtraction function inside the b.py file and not inside the a.py file. Now, since you know why do we need to import modules, let's see how we can actually use a function by importing the module. More or less, we are interested in using the function in different modules. So there are different methods of importing a function. The first is where we directly import the function we are trying to use. Also, an import statement looks like this. For example, if you want to use the addition function that resides inside the arithmetic module, and this arithmetic module in turn resides inside the operator package. So what we can do is we can use the addition function by from operator.arithmetic import addition. So let me break this down to you. Import is a command that actually lets you import this function, and from tells from where this addition function needs to be imported. So if you want to use the addition function now, we can directly use the addition function and supply in the parameters. The other method to import is by importing the module rather than the specific function. So for example, we can import the arithmetic module from the operator package. Now, when we want to use the addition function, I can use a dot operator to access this function which resides inside this module. So, addition will be called by arithmetic.addition supplied by the parameters. So this is how we can import a module in a Python function. This video is about Pandas, an efficient library for data handling and manipulation. Let's see all the topics that we'll be covering while studying about Pandas. First, we will have a brief introduction of Pandas. Next, we will see why should we use Pandas. Then, we will come to how we can read a spreadsheet in Pandas for analysis. Then, we will have a look at data frames, which is a way Pandas stores data for analysis, and some of the basic operations that can be performed on data frames. Next, we will move to some advanced operations and see how we can perform indexing in DataFrame. We will also see how we can select, add or delete columns of a data frame. Next, we will have a look at how we can subset a data frame, and lastly, we will see how we can export a data frame to a spreadsheet. So these are all the topics that will make up the Pandas section. But in this particular video, we will only have an introduction of Pandas along with why to use them and how to read a spreadsheet. Let's get started. So what is Pandas? As it turns out, Pandas is a very powerful and widely used library in Python for reading, filtering, manipulating and exporting data. That means it is a library which can perform all the functions required for processing data, and that too very efficiently. But then why should we only use Pandas and not other library for the same task? It is because of the functionalities provided by Pandas, such as it can read different varieties of data like CSV, Excel, JSON, etc. Also, it has functions for filtering, selecting, and manipulating data. Along with data manipulation, Pandas has support for visually exploring the data. Another major reason to use Pandas is that it has huge contribution from the developer community. Hence, there are many high quality functions for all the tasks that you can think of. Let's move to the next part of reading spreadsheets in Pandas. But before that, let us have a look at the different file formats that Pandas can read. Pandas can read a wide variety of files such as CSV, JSON, HTML, local clipboard, Excel, HDF5 and so on. And these are the functions that read these different file formats. But we will focus on two files in particular, the CSV and the Excel file format. We can use the read underscore CSV function to read CSV files and read underscore Excel function to read Excel files. In the next video, we will see how we can read a dataset present in CSV and Excel format in Jupyter using Pandas. In this part of the video, we'll be seeing how we can read a CSV and Excel file inside Pandas. So our data is present inside two files. First is a CSV file named data.csv and second is a file named data.excel. So let's start by importing the important libraries first, that is Pandas. Now that we have imported the required library, let us first of all read the CSV file. CSV file can be read in Pandas using the read underscore CSV function. The file that we are going to read is data.csv. So first of all, let's create a variable, that is the df, which will store the data frame. Now what we can do is we will call the read underscore CSV function inside the Pandas package. Now we need to supply it the name of the file that we want to read, that is data.csv, and when we run this, we can see that this file has been read. So to confirm that our file has been read, what we can do is we can check the first few rows using the head function. So when we do something like df.head, it returns the first few rows. So this confirms that our CSV file has been read properly. We'll see how we can read an Excel file inside the Pandas. So to read the Excel file, we'll be using the read underscore Excel function. Now let's move on to reading the Excel file format. Reading Excel file format is very much similar to the CSV file format. The only difference is in this function. We'll be using the read underscore Excel function to read the Excel file. Let's store the variable df1 inside this Jupyter notebook, which will contain the data frame. Now let's use the read Excel function. The name of the file that you are going to read is data.xlsx. So when I read this, let's just print the first few rows of this data frame and see if everything works fine. So we can see that the read Excel function has worked properly and we are able to read the first 5 rows of the data.xlsx file. So these are the basic operations that we are talking about on reading the CSV and Excel file format. In the previous videos, we had an introduction to Pandas and we read datasets in CSV and Excel formats. In this video, we will discuss about DataFrame, a data structure native to Pandas, and some basic operations that can be performed on it. Let's get started. So, what is a data frame? A data frame is very much similar to Excel sheets and a data structure used by Python to store and manipulate its data. On my left is an Excel worksheet and on my right is a Pandas data frame. Both of them look the same, but with a few noticeable differences. See how the row index in the Excel worksheet starts with 1, whereas in data frame it starts with 0. Also, a particular cell in Excel sheet is indexed using a combination of row and a column, whereas in data frame there are lots of ways to access the data, which we will see later. Now, let's have a look at some of the basic functions of a data frame. We can check the dimensions of the data frame, which is the number of rows multiplied by the number of columns using the shape function. Also, we can access the top and bottom records of a data frame using the head and tail function respectively. We can also access all the column names in a data frame using the columns functions. Also, to access a particular column, we can use these square brackets with the name of the column that we want to access. In order to access multiple columns, we need to pass the name of the columns inside the list. So this is the list which can access column 1 and column 2 data. So this was all about the data frames and its basic operations. In the next video, we'll see how we can read a dataset in Python, convert it into a data frame, and perform some basic operations on them. In this video, we'll be performing some basic operations on a Pandas data frame. So let's get started. First of all, let's import the required libraries. We'll be importing the Pandas libraries first to perform these basic operations. Now that we have imported the Pandas library, let's import the dataset first. The dataset is given in a file named data.csv. We'll be using the read_csv function to read the CSV file. Now that we have read the CSV file inside Pandas and stored it in a variable named DataFrame, that is df. So let's now start with performing some basic operations. We'll start with performing the basic operations by seeing the dimensions of the df data frame. We can see the dimensions of the data frame using the shape function. So let's use the shape function on the df data frame. So we can see that it has returned a tuple where this is the number of rows and this is the number of columns in the data frame. Let's now have a look at the top 5 rows of the df data frame. We can have a look at the top 5 rows using the head function. So let's just use the head function on the df data frame. So you can see that the head function has returned the first top 5 rows of the df data frame where we have the columns like id, column thickness, cell uniformity, etc. And these are the rows which starts from index 0 and ends at 4. Now what if we want to see the bottom 5 rows? We can do so using the tail function. So these are the bottom 5 rows returned by the tail function. We can also see more than 5 or any number other than 5 by specifying that number within these brackets. So for example, if I want to see the bottom 10 rows instead of 5, I can supply 10 inside this bracket and it will return me the last 10 rows. Now let's move on to our next basic operation, that is seeing all the column names together. So we can see the column names using the columns function. So let's just use the columns function on the df data frame. Here we can see that it has returned all the names of the columns that are present inside the DF data frame, that is ID, clump thickness, all the way up to the cancer type. So this is how we can see the column names at a single place. Now, what if we want to select a single column? We can easily do that by indexing it. Let's see how we can select a single column. We can easily select a single column using its name. So, for example, if I want to select a column named bare nuclei, what I can do is I can write it as df and the name of the column within these square brackets. So, when I do something like this, it is going to return all the data of the column that we wish to expect. And now, what if we want to select multiple columns using names? That can be easily done too. To select multiple columns using names, we can pass a list to inside these square brackets instead of a single string. So for example, I can do something like, first of all, let's just select the bare nuclear data that we already selected. Next, let's select the cancer type data. So when we pass in this list to the DF data frame, it will return the data of both these columns. So as you can see that this has returned both the data in these two columns. So these are the basic operations that we can perform in Jupyter using Pandas. In the previous video, we had a look at the introduction to Pandas. We saw how we can read in spreadsheet. Also, we saw what is a data frame and we performed various operations on a data frame. In this video, we'll be working on a few more topics. That is, first of all, we'll see how we can index or select data in a data frame. We'll also see column selection, addition and deletion. Also, we'll see how we can subset in a data frame. Finally, we are going to see how we can export our data frame to CSV and Excel file format. We'll be performing these operations in a Jupyter notebook for easy clarification. So, let's just switch to Jupyter notebook. So this is the notebook that we'll be working on. So let's get started. We'll be importing the Pandas library first so as to perform the operations of indexing and selecting. Now that we have read the Pandas library, what we are going to do is we are going to read the dataset first. We are going to read the dataset using Pandas read_csv function, and we are going to store the result in a variable called df. The dataset is stored in a file called data.csv. So I'm going to supply this to our read_csv function. Now that we have read the dataset, let's see the first few rows of the dataset using the head function. So this head command is going to show us the first few rows. As we can see that this is a dataset of cancer detection that we have previously worked on. So we have some columns like ID, clump thickness, cell uniformity, etc. And we need to predict the cancer type. Okay, so let's start with the first operation, which is selecting a single column. So let's say we want to select the bare nuclear column of this dataset. We are going to select the bare nuclear column using its name. So how is this done is, first of all, we are going to write the name of the data frame, the brackets, and inside these brackets the name of the column that we wish to select. So for example, df bracket and inside the bracket bare nuclei will give access to this column. So here we can see that this is the bare nuclei column that we have. Now in order to select multiple columns, we are going to supply a list to inside the square brackets. Selecting multiple columns using names is as easy. So what we are going to do is we are going to write the df, then within these square brackets we are going to supply the name of the columns that we wish to select. So for example, if I want to select the clump thickness, I'll mention that it here. And suppose the second column that I wish to select is marginal adhesion. So when I run this cell, I can see the output of the command. I have the data of the clump thickness and the marginal adhesion of all the rows. So this was how we can select multiple columns by their names. Now what if we want to select rows by their positions? We are going to select rows by their positions using the iloc function. So for example, let's say if I want to select the first 5 rows of the df data frame. So how I can do that is df.iloc and to the ilog I am going to supply the range of the rows that I want to select. So for example, if I do something like this, so what it is going to do is it is going to start from 0 and go up till 4. So it is going to select row number 0, 1, 2, 3, 4. That is the first 5 rows of our DF data frame. And when I run that, you can see that it has selected 0, 1, 2, 3, 4 and all the columns of these rows. So this was how we can select rows by their positions. Now what if we want to select columns using their positions? Similar to the row case above, we can use the ilog function to select columns by their positions. So for let's suppose if I want to select the first 2 columns of the DF data frame. So what I'm going to do is I'm going to write something like this. So let me make it easier for you. So anything before this comma represents the rows and anything after this represents the columns. So colon here means select all the rows and colon 2 here means start from 0 and end at 1 index. So this command is going to select the first 2 columns of the DF data frame. So when I'm going to run this command, it is going to return the ID and the clump thickness. So this was how we can select columns by their positions. Now, what if I want to select rows based on some sort of condition? So let us first have a look at the dataset first. So for example, let's just select the rows where the cancer type is equal to 2. So what I can do is df, then inside these brackets is going to be my condition. So since I am making a condition on the cancer type, so it will be df, inside that the column name cancer type. So we want the cancer type rows for all the cancer type equal to 2. So what it is going to do is it is going to return a position vector basically where all the cancer types are equal to 2, and then it will subset the DF data frame according to these. So when I run this, what will happen is it will return all the positions where cancer type was equal to 2. I can also check it for some other number. For example, let's say if I want to check it for 4, and it will going to return me all the rows where cancer type is equal to 4, as you can see it here. So this was all about how we can subset, index, slice a data frame using pandas. And this was into the pandas module. I hope you have learned a lot.
In this module, we'll be working on data manipulation and data exploration through visualization. Let's start with data manipulation using the wonderful Pandas library. Pandas is easily the most widely used Python library for data science. It's incredibly helpful in manipulating the data so that we can derive better and more meaningful insights, and of course, build great machine learning models. In this notebook, we'll have a look at some of the intermediate concepts of working with the Pandas library. So, we look at two things primarily in this and the next video, which is sorting data frames using Pandas and of course merging data frames. We'll be working primarily with the Big Mart sales data. This data set is basically sales data for tons of products across 10 stores in different cities. Also, certain attributes of each product in store have been defined in this data set. So we'll import numpy as np here, and we'll read the data set, drop any missing values, and use the dot head function here to look at the first 5 rows of our data set. So let's go ahead and do that. Here we go. So as I mentioned, it's sales data for a lot of products. So we have item weight, fat content, visibility, item type, was the MRP of the item, and so on. And of course the sales numbers here in the final column. Alright, so let's get into it. First thing we look at is sorting data frames using pandas. So the pandas data frame has two useful functions, sort underscore values and sort underscore index. The sort underscore values function is used to sort a pandas data frame by one or more columns, and sort underscore index, as you might have guessed by the name, is used to sort a pandas data frame by the row index. Each of these functions come with numerous options like sorting the data frame in a specific order, sorting in place, sorting with missing values by a specific algorithm, and so on. So let's say we want to sort the data frame by the outlet establishment year variable, which is basically this one. So here we'll use a sort underscore values function, right? And here's the code to do that. all we have to do is dot sort underscore values, and we are passing the variable name here. And we look at the first 5 rows of the sorted data. Here we go. As you can see, it has been sorted out in ascending order. Just check out the original column and the sorted column. Makes sense, right? Now, sort values takes multiple options, such as ascending and in place. Let's look at these two in code form. So here we're using the outlet establishment here variable again. Now we're setting ascending is equal to false. That means you want the column to be sorted in descending order. And in place is equal to true. That means you want the changes, the sorting changes, to reflect in the original data frame, right? Here we didn't say in place is equal to true. That means these changes did not reflect in the original data frame. They were just stored in a new variable or data frame called sorted underscore data. So let me just go ahead and run this. And here we go. As you can see here, outlet establishment here has been sorted in descending order. Now there might be occasions when we want to sort a data frame based on the values of multiple columns. In fact, it happens a lot in the industry, in the real world. Now we can specify the columns we want to sort as a list in the argument of sort underscore values. So here I'm again reading in the data set, because remember we had already made the sorting changes permanently in the original data frame. So we'll have to recall the data frame that we have to work with. Again, we'll drop the missing values. And now we're using two columns, outlet establishment year and item outlet sales. And of course, we're setting ascending is equal to false because we want the function to sort it in descending order. Let's look at the first 5 values. Let's see what happens. What do you think? When I pass in two variables, which one will it sort first? Well, in Pandas, the sort value function uses the first variable to sort first and then the second variable. So in our case, outlet establishment year has been sorted first in descending order and then the item outlet sales variable. And we can see the difference by switching the order of column names in the list. So let me go ahead and do that. Here I'm passing item outlet sales first and outlet establishment year second. And just for your information, I'm putting in place is equal to true here. Alright. As you can see here, now item outlet sales has been sorted in descending order first and then outlet establishment here. Compare it to this. We had this first and this second. So that's how you can sort in descending order for multiple variables. We can use sort underscore index as well to sort a Pandas data frame by the row index or name. In this example, row index are numbers. These numbers that you're seeing here, these are the row index. And since we've already sorted the data frame by two different variables, therefore these row index numbers are all mixed up. Let me just show you again. Look at this. It's all mixed up. It's not in any order at all. So using sort underscore index, we can retrieve the original data frame. So let's just do that here. And here you go. As you can see, the row index has been restored to its original order. And the sorting that we did has been reverted to whatever we had in the original data frame. So that's how we can perform sorting in a data frame using the Pandas library. It really is that easy, and I hope you try it out by yourself. Use any dataset that you want. It's a very easy function. Just see how you can play around with this. In the next video, we'll look at how do we merge data frames using Pandas. Now that we've seen how to sort data frames in Python using Pandas, let's look at another very useful function in Pandas, that's merging data frames. So joining and merging data frames is one of the most core processes that we as data scientists use in data analysis and for machine learning tasks. Because there'll be a lot of occasions when you're working with data that comes from multiple sources and there are multiple files to work with. So in this video, we look at two very useful functions for merging data frames that are present in Pandas, concat and merge. The merge function is used to combine data frames on the basis of values of common columns. And the concat function is used to append data frames one below the other or sideways. So let's look at both of these functions in detail. So we'll start with the concat function first. We'll create dummy data here. So I'm creating 3 data frames, df1, df2, df3. These are the column names, these are the values we're passing, and these are the column index that we're giving. So let me just run this code block. Alright, so these are the 3 data frames that we have. And now we want to combine them row-wise so that they become a single data frame. Again, this is a very common function in data science. And this result that you're seeing in this image is what we want after we combine these three data frames. The concat function comes in very handy here. All we have to do, as you can see in this code block, is just pass the three data frames in the .concat function. That's it. So let's run this code block and see what the result is. And as you can see here, the .concat function has combined the three data frames row-wise. Pandas actually also provides us with an option to label the data frames after we have done the concatenation function. So we can do this using a key so that we might know which data came from which data frame. So as you can see in this code block, we are passing X, Y, Z keys. Basically recognize which data comes from df1 and we'll put the key as X for df1. For df2 it's Y, for df3 it's Z. So let's print this out and see what the result is. Perfect. As you can see, we are now easily able to recognize which observations or records come from which data frame. X again represents df1, Y for df2 and Z for df3. Makes our life way easier now. You can also retrieve the data of say data frame df2 which had the label Y, as you can see here. And we can do this by using the lock method or LOC method. We have covered this before and we'll cover it again in a bit more detail later. So let's just run this and see what result we get. Perfect. So we've extracted the second data frame, df, for which the key was Y, and all these records have now been extracted using just the .loc function. It's that easy. Now, when we are gluing together multiple data frames, we have a choice of how to handle the other axis, other than the one, of course, being concatenated. Now, we can do this in three ways. One is by taking the union of all the records, using join is equal to outer. This is actually the default option which we have been following so far. Second is by taking the intersection of all the records, basically what records are common. And we can do this by join is equal to inner. And the third way is by using a specific index as passed to the join underscore axis argument. Let's look at an example of each of these methods and just keep in mind that we'll now do this column wise. So far we were doing it row wise, right? Now we'll focus on columns. So the first example is we'll use the default join is equal to outer behavior. So we have df1 and df4 here with these values, and this is the result that we want after using join is equal to outer. So let me just run this code block and let's see what we get. Alright, so what do you think happened here? If you want, you can pause the video for a second and just think about what this result means, how it came to this. So remember, join is equal to outer means taking the union of both the data frames. So both df1 and df4, all the values are in this. Now I want you to focus on the row index. Row index 0 in df1 is not present in df4. That's why there are NaN values here. Now row index 2 is present in both df1 and df4. That's why you'll notice that all these values are full. There are no NaN values. And it's similar for say index 6 and 7 in df4, which is not present in df1. And that's why there are NaN values here. It's really that simple. That's how outer join works. And you might have already imagined what inner join does. It basically takes the intersection of the two data frames. Whatever row index are the same between the two data frames, it'll output that. So when we have df1 and df4 here, this is the result that we want. Let me just run the code and perfect. This is exactly what we've gotten. So again, focus on the row index. Notice which row indexes are common between these two. 2 and 3, right? And that's exactly what we have in the output. We don't have 0, 1 and 6, 7 since they don't intersect in terms of the row index. Next, we look at the merge function. For those of you who have worked with SQL before, worked with MS Access or any database before, you'll understand exactly what I mean by merge. Two data frames might hold different kinds of information about the same entity, and they might be linked by some common feature or column, right? So far, using the concat function, we were basically appending data frames one below the other or sideways. Using merge, we will now combine data frames on the basis of values of common columns. So let's see how to do that. Let's create some dummy data. Here you're working with some student information, some very basic student information. So we're creating three data frames. The first two have the subject ID, first name and last name of the student. And the third data frame has subject ID and the test ID. The keen-eyed among you might have noticed that subject ID is the common link between these three data frames. And here's a tabular representation of the three data frames that we've just created. So let me just run this. Okay, perfect. So let's start with a basic join. we want to combine the first data frame and the third data frame based on the subject ID column. So we'll use the dot merge function here and just run this code. And here we go. So I'll just pull up the two data frames. Remember, subject ID is the common link between DFA and DFC. So we have subject ID, first name, last name, and test ID in the resulting column, and that's exactly what we have here. Our merge function worked out perfectly. So now that we've done a very basic join, let's get into some common SQL joins. First is the merge with outer join. So pay attention to this image. So the area which is falling between the two green bars is essentially the records that have matching values for subject ID. And this are basically unique to that particular data frame. Don't worry, we'll look at an example to understand how this works. And of course, we've already done outer join just a few moments before, so just keep that in mind as we run this code. So just take a look at this. What do you think happened here? Now, we performed the outer join on the subject ID column. So I want you to pay attention now to these two data frames that you're working with right now for this particular join. Subject ID 1 and 2 and 3 are not present here in the second data frame. So that's why we have NaN here. Subject IDs 7, 6, 7 and 8 are not present in the first data frame. That's why we have NaN here. So again, the same logic that we saw in outer join in the concat function applies in the merge function as well. Consequently, let's look at the merge with inner join. Again, remember, inner join is all about the intersection between the two data frames. Anything that's outside the common observations will be eliminated and we'll only access what's common between the two data frames. So all I'm doing is I'm passing subject ID as on and how is inner. And we've extracted only those observations using the subject ID column which are common among the two data frames. Next is merge with right join. Right outer join basically produces a complete set of records from the second table with the matching records where available in table A or table 1. If there's no match, the left data frame will contain null. So I'm going to go ahead and run this code block and you'll see exactly what I mean. Again, I'm working with the first and second data frames only. So remember what I just said. We have a complete set of records from the second table. So that's table B in our case, or data frame B. And whatever is common between the two in data frame 1 will be taken. That's why we have a ton of NaN values. So notice now the subject ID 4, 5, 6, 7, 8, and that's exactly what we have here. The complete set of records from data frame 2 are present. You might have noticed that we have underscore X and underscore Y in the results that are coming out. This is nothing other than what we saw in the concat function. Underscore X basically represents the first data frame and underscore Y represents the second data frame. That's all there is to it. It basically helps us identify which values are coming from which data frame. Next, we look at merging with left join. Again, now that you understand right join, left join is basically the other part of it. It produces a complete set of records from the first data frame with the matching records where available in the second data frame. And if there's no match, you might have guessed it, the right side or the second data frame will contain null. So let me just go ahead and run this. Alright, perfect. So here we have all the observations from the first data frame on the subject ID. So 1 to 5 we have here. And we don't have 6, 7, 8 since it's not matching. And that's why those values from the second data frame have been dropped. That's all there is to it. Now you might be wondering, merge or concat, which function should I use and when should I use each? We mentioned this earlier as well at the start of the video. One major difference between these two functions is that the merge function is used to combine data frames on the basis of values of common columns, and the concat function is used to append data frames or stack data frames one below the other sideways, depending on whether the axis option we are setting is 0 or 1. The exact usage depends upon the kind of data we have and the analysis we want to perform. So that is all we had for merge and concat, two very useful pandas functions. Let me introduce a new function called apply. This apply function can be used to perform pre-processing and data manipulation on our data both row-wise as well as column-wise. It's actually a faster and more efficient method than simply using a for loop over our entire data frame. If you've followed or looked at winning solutions in data science competitions, both in Analytics Vidya or any other platform, you'll have noticed that especially during the feature engineering part, especially of the people who come on top of the leaderboard, the use of the apply function is ubiquitous. In fact, I would encourage you to next time pay attention to this whenever you're looking at the code of the leaders. So let's look at how to use the apply function in Pandas in this video. So first, just a reminder that we are working on the Big Mart sales dataset in this video as well. So let's access our dataset row-wise using the .apply function. And don't worry about the lambda function here. So let's just see what the result is. Alright, so here we have the dataset, Big Mart sales dataset row-wise. The lambda function here might look complicated, but don't worry about it. In this case, it's just there to access each object over which the apply function iterates. The x that we're seeing here is the variable that is used to make manipulations in each object that is iterated upon. And when I say each object, I mean each row in this dataset. That's it. That's what lambda does. You'll understand what it does better when we see further examples. So let's access the first row of our Big Mart sales data. So let's just run this code and let's see what we get. Alright. To access the first row, all I've done is I've input 0 here to tell the apply function just to extract the first row from the dataset or access the first row from the dataset. And we can verify it. Just look at item identifier is the same, item weight 9.3, 9.3 and so on. It's basically the entire first row that's been accessed here. Next, let's access the first column. The only difference between this code and this code is that we are setting access is equal to 1. Basically, we're telling the apply function to now access the dataset column wise. And we extracted the first column, which was item identifier. And these are all the values from the item identifier column. Now let's access by column name. So instead of the column index which we've been working with, so we are saying 0 here. Now let's input the column name. We'll work with item fat content. And access is equal to 1 again because we're working with columns. So let's see what we get. Perfect. So we have all the observations from the item fat content column here. We can also use the apply function to implement a certain condition on every row or column of the data frame that we're working with. So what if in the Big Mart sales data, I want to say clip the item MRP to 200 and not consider any value greater than that. So what I mean by clip is any value that's over this set value of 200 will be clipped down to 200 and any value below 200 will be essentially kept the same. So this is the function we'll use. Don't worry, I'll just show that in code form to you. So before clipping, the first 5 records in the item MRP column are present here. Alright, we can clearly see the first row has a value above 200. Let's see what clipping does. In this code, we're basically defining a function clip underscore price and we're saying if the price is greater than 200 or is equal to 200, just clip down that value to 200. That's all we're doing here. And we'll use the apply function and let's see the first 5 rows. Perfect. Notice the difference between the two outputs. Every value is the same except the first one. So 249 has been clipped down to 200 and that's what this code did for us. And that's why the apply function is so useful. There's a lot more that we can do with the apply function. Let's say we want to label encode a variable. We'll take outlet location type. So before I look at this example, just think of any categorical variable, not just in this data set, any categorical variable you worked with. Machine learning models work well when we input numbers in the data. They don't work well with text, and some don't even work at all with text. So it's always best to label encode the data as 0, 1, 2, etc. so on for the categories that we have in our data set. So in this Big Mart sales data, we'll use 0, 1 and 2 to represent tier 1, tier 2 and tier 3 cities in the outlet location type column. And we'll use this function to do that. Again, we'll look at this function in code form. So let's look at our data before we label encode it. So again, as I mentioned, the outlet location type column has tier 1, tier 2 and tier 3 cities, the 3 categories. Now we'll define a function to label encode these. Basically, we are defining a function label underscore encode and we're saying if city is equal to tier 1, the label for that should be 0, for tier 2 should be 1 and for everything else should be 2. And everything else is of course tier 3 in our case. And we are applying the label encode function here on the outlet location type column. So I'll just run this code and let's look at a result after we've done this. Perfect. So we now have the different categories encoded in numeric form. So tier 1 is 0, tier 3 is 2 and tier 2 will of course be 1 which is not here since we're only looking at the first 5 rows. There's a lot more, as I mentioned, you can do with the apply function. This is the very core of it. And I encourage you to play around with the apply function, pick up data sets. In fact, you can pick up this particular data set and just see how and where you can use the apply function. Trust me, it will be very helpful for you when you're working in the industry or in data science competitions. You'll be stunned at the results you get. So far, we've seen sorting data frames and merging data frames in Python using Pandas. Let's turn our attention to aggregating data. So here we'll be working with a now familiar Big Mart sales dataset, and let's import the libraries pandas as pd and numpy as np, and we'll read the dataset, drop the null values, reset the index after dropping, and let's view the top 5 rows by using the dot head function. And here we go. We're very familiar with this dataset. So let's look at how do we aggregate data using pandas. Aggregating data is an essential part of data analysis. It helps us generate summaries of the data and gives us an intuition or feel of the data that we are working with. Now, there are multiple functions that we can use to perform very useful aggregations on the data using the pandas library. These are group by, cross tab, and pivot table. So, when I was looking at this data, a few questions popped up, and we'll try answering those questions using these three functions. So, the first question was, what is the mean price for each item type, right? And we'll use the group by function to find the answer to this. Group by is basically taking data and grouping it into buckets. So let's code that out. So here we'll use the group by function and pass the item underscore type variable. And let's just look at the first few rows here. Do you see the difference between the original data frame and what we just did here? We've grouped the rows together by item type. Our original data set had the row index as 0, 1, 2, 3, 4 and so on. Now our row index is the item types. So we have baking goods, breads, breakfast, canned, dairy, etc. This is the row index. Alright, now that we've grouped the rows by item type, the next step we'll do is we'll calculate the mean of item MRP. Remember, the question we're answering is what is the mean price for each item type. So let's get to the mean price now. So we'll just find this out. Perfect. So now by doing this, we have the mean price for each item type in our data set. So for instance, dairy has multiple products. It could have cheese, it could have milk, butter and so on. It's all grouped together in dairy and we have the mean price for that particular data type. And that's how it works for the entire item types here. You can even use group by with multiple columns in your data set. And that is a very useful function. So here, as you can see, we're using item type and item fat content as well. So let me just run this and we'll see what output we get. Alright. So did you notice the difference between the first group by and the multiple group by? Here, the group by function is grouping the first column item type and then the second column item fat content. And we intuitively can deep dive into the data after this. There's a lot more that we can do with group by. You can explore multiple columns on your own. In fact, I recommend that you play around with group by. It'll really help you understand how it works and it'll help you understand the intuition behind the data as well. Next question that I had in mind when I was looking at the Big Mart sales data was how are the outlet sizes distributed based on the city type? So remember, the city type was tier 1 city, tier 2 city and tier 3 city, and outlet sizes were basically high, medium and low. So I wanted to see, my first intuition was, will a tier 1 city have a bigger outlet size? And so on. So what crosstab does is, it builds a cross tabulation table that shows us the frequency with which certain groups of data appear. So let's just run this code and we'll see what crosstab does. Pretty interesting output here. So as you can see here, the tier 3 cities have the highest outlet size, and the highest outlet size is not present in tier 1 and tier 2 cities. And 50% of medium size outlets are present only in tier 1 and tier 3 cities and none in tier 2 cities. Very interesting data. It's actually counterintuitive to what we had initially thought, that tier 1 would have the highest outlet size. This is exactly how aggregating data helps us understand the intuition behind the data set that we have. And the third question was, how are the sales changing per year? I'm sure a lot of you can relate to this question. And to answer this, I lean on a function that all of you Excel users will be very familiar with, and that is the pivot table. We can use the Pandas library to create MS Excel style pivot tables inside our Jupyter notebooks. How cool is that? So here the pivot table function has a few parameters that you should be aware of. First is the data, which is fairly self-explanatory, right? It's the data frame that we're using. Index is basically the column we want to group by, and values is the column you'd like to aggregate. So as you can see in this code, values is item outlet sales and index is outlet establishment year. So you want to group the sales by when the outlet was established. So let's run this code. Perfect. So as you can see here, we have the outlet establishment year and the mean sales of the outlet. The pivot table function uses the mean by default. That's a very useful feature to have. So here, based on the establishment year, we're getting the mean sales. And you can just follow along as we go. We can also pass multiple columns to a pivot table, just like we can do in Excel. So now let's try to see the mean sales, not just by the year, but let's include the outlet size and the type of the city. So that's exactly what we're doing here. We are including outlet size and the location type, which was again tier 1, tier 2, tier 3. We're passing that into index here. So let's just run this. Alright, as you can see here, does this look familiar to you? A very Excel-like pivot table. So we have the outlet establishment year, what is the location type of that outlet, what is the outlet size, what are the mean sales for that outlet. And that's how a pivot table works. So much information packed into such a small table. Pivot table is truly one of the most awesome functions in Pandas and frankly anywhere that we want to do data analysis. But we can also perform multiple aggregations like median, minimum, max, standard deviation in a pivot table. And we can do this using the ag_func parameter. So as you can see here, I'm passing mean, median, min, max and standard deviation to ag_func. So let me just code this and let's see what the results are. Perfect. So we had just the mean sales here, right? Now we have mean, median, minimum, maximum and standard deviation of the sales for the outlet based on the establishment year, the location type and the outlet size. This is the true power of pivot tables and aggregating data using Pandas. Data visualization is one of my favorite aspects of the machine learning lifecycle. There is so much information that we are able to unearth just by visualizing the data. In fact, making plots and static or interactive visualizations is actually one of the most important tasks in machine learning. It's often used when we're exploring the data. For example, if we need to identify outliers or we need to extract any patterns or trends that might be hidden in the data that were not manually found out before, etc. And Matplotlib is one of the most popular and extensively used libraries of Python for data visualization due to its high flexibility and extensive functionality. So what we'll do in this video is we'll set up Matplotlib in our Jupyter notebook and look at a few basic components of Matplotlib. So how do we make a simple plot? How do we add labels, legends? How do we play around with colors, figure sizes, etc. And in the next video, we will deep dive into how to create different charts using Matplotlib. So let's get into it. First is we set up Matplotlib in a Jupyter notebook. So it's a very simple command to import it. It's import matplotlib.pyplot as plt. That's it. Remember we do this for pandas and numpy as well. It's a similar line of thought here. And we can also use %matplotlib inline here. Basically this helps us generate different visualizations within this Jupyter notebook itself. And of course, you can explore a lot more about Matplotlib on the official documentation page of the library here. Alright, so let's get into the code. Here, I'm first importing the required libraries, numpy as np, pandas as pd, and of course, matplotlib.pyplot as plt. So let me go ahead and do that. And of course, we're using this %matplotlib inline as I just mentioned earlier. So let's look at some basic components of Matplotlib. Let's see how to make a simple plot. Here I'm using two variables, height and weight, with these values. So I'm going to use a .plot function to simply plot these values. Here we go. That easy, right? But here I'm not sure what the height is, where the weight is, what's on the x-axis or the y-axis. So what we can do is we can customize our plot by adding titles, labels, and legends. So let's do that. So let me just run this code block and then I'll run you through what we just did. Here we go. So here using the dot title function, we've added, as you can see here, the title of the plot. Dot x label tells us the name of the x-axis and dot y label tells us the name of the y-axis. All right. Let's look at another variable, calories burnt, and the values are here as you can see. So now what I'll do is I'll draw the plot for calories burnt and for the weight variable we saw earlier. All right. Just think about this for a second. Can you figure out which line represents weight and which line represents calories burnt? It's not intuitively possible, right? This is where adding legends really helps. So what we'll do is we'll again plot calories burnt and weight, but this time we'll add legend in the lower right part of the figure. So let me go ahead and plot this. Perfect. As you can see, we have calories burnt and weight here. So the orange color is the weight and the blue color is the calories burnt. Much more intuitive now. Of course, you can play around with the location. It's lower right here, but you can do upper right, upper left, lower left, etc. But look at the x-axis. What does this represent? Can you figure that out? Can we add labels to show that each point here belongs to a different person? For example, this point belongs to person 1, this to 2, this to 3, this to 4. Can we do that? We certainly can. The labeled values on any axis are known as ticks. So we can simply use x ticks to change both the location of each tick and its label. Let's see how to do that. I'll just plot it and you can see it perfect. As you can see the x-axis here, we have this for person 1, person 2, person 3 and person 4. Our plot now makes a lot more sense. And how did we do this? Just check out this last line. X ticks 0, 1, 2, 3, which represent person 1, person 2, person 3 and person 4. And we can further play around with this plot to customize it. We can specify the size of the figure using the function figure and passing the values as a tuple of the length of rows and columns to the argument fixed size. Don't worry, we'll just see how to do that. And just a point to note here, the values of length that Matplotlib takes are in inches. So let me go ahead and run this. So what have we done here? First, we've passed the argument figure size in inches here, 15.5. We're doing this so that we can expand the plot to get a better sense of how wide it is. And of course, we've added the legend in the lower right part and set the ticks for the different people that we have in our data set. All right. Next, we can play around with the colors. The default format, as we've shown here, is B dash, which means a solid blue line. Basically, the first letter here represents the color. The second letter represents the shape of that actual data point. Right? So let me just run this and you'll see what I mean. So here, for the weight variable, I'm using y dash dash, basically yellow color, and I want a dotted line, as you can see here. For calories burnt, I haven't passed any particular argument. That's why it's taking B dash as the format. So let's take go here and see what happens. Perfect. So did you see what I did here? G here represents green and O is basically that we want the data point to be represented as a circle, as you can see in this plot. So you can just play around with this Jupyter notebook, try out different colors, try out different shapes. It's quite a fun exercise. We can actually plot multiple sets of data by passing in multiple sets of arguments of x and y axis in the plot method as shown. Alright, we can use subplots to add more than one plots in a figure. It actually happens quite a lot in real life. What if you want to compare two different charts? So subplots takes two arguments, n rows and n columns, basically the number of rows that we want and the number of columns. And this method creates two objects, figure and axis. So let me just go ahead and run this and you'll understand exactly what I'm talking about. So here I've given the number of rows is 2 and the number of columns is 2 as well. And we're setting the figure size to 6 by 6, basically the length and breadth. And this is what we get. So we get 2 rows and 2 columns as we had specified. And when I said axis, this is how Matplotlib works using the subplots function. This is axis 0, 0. This is 0, 1. This is 1, 0 and this is 1, 1. If you've seen any graph, you'll understand what I'm talking about. So here for 0, 0, which is basically the first plot, I'm saying plot calories burnt and use go, basically green color and O as the shape, and that's what we get here. On 0, 1, I'm plotting simply the weight and it's taking B dash by default. I'm sure you remember we just covered this earlier. And then we're setting the title, we're setting the ticks, etc. Notice that we have two empty plots because we're only working with two variables, calories burnt and weight. So these two are essentially useless. But we had passed two rows and two columns, so they had to be generated. And another thing, notice that there's a lot of repetition. On the y-axis, you can see we have certain values, they're being repeated here again, here and here as well. It's kind of pointless. It adds to a lot of clutter. So there will be times as a data scientist when you need to have a common axis, a common y-axis for all your subplots. And it's actually very simple. You can do this by using the share y parameters of subplot. So this is essentially the same code block we saw earlier, except now I'm passing share y is equal to true. And of course, I'm setting the number of rows as 1 and number of columns as 2. So we've eliminated the two empty plots. And of course, now we have one common y-axis. Looks a lot neater and more tidy. You can learn more about subplots here when you get this Jupyter notebook. Just go to this Matplotlib page and there's a lot more you can experiment around with. So that was all for this video. In the next one, we'll take up a very interesting data set and deep dive into the different chart types that we can generate using Matplotlib. It's a very interesting video. Now that we have a sense of what Matplotlib is, how it works, how do we import it, and how do we customize plots, let's do one thing. Let's take a data set and see how we can generate different plots and charts using Matplotlib in Python. So in this video, we'll be working on the Big Mart sales dataset. This dataset is basically about sales data for tons of products across 10 stores in different cities. Of course, there are certain attributes of each product and store that have been defined. So let's read the dataset, drop any missing values, and we'll view the first 5 rows of our dataset using the .head function. So let me go ahead and run this code, and here we go. So we have a lot of variables here. We have item identifier, we have the weight of the item, fat content, what is the visibility, what item type it is, what's the MRP, etc. And of course, as I mentioned, this is sales data. So the final column here is about the sales numbers. So let's use visualization to answer a few questions you might have around this data set. It's actually a wonderful way of exploring your data before we get to the model building part. This is exactly how we unearth patterns and identify insights in a typical machine learning project. So we'll start off with the line chart. The first question we are trying to answer with this line chart is, what's the mean price per item? In Matplotlib, line chart is the default plot when using the plot function. Before we get to that, let me just use the .groupBy function on the item type variable to figure out the mean price per item. And let's do that. Here we go. So as you can see, the item type is here and the mean price for each item type is in this column. Perfect. So now let's plot this and see the line chart that we get. And here we go. So as you can see, we have item type on the x-axis and we have the mean price for each item type on the y-axis. We've gained so much information using such a simple plot. Isn't visualization wonderful? Let's see what we did here. Here, we're setting the x as price by item dot index. Index is nothing but the item type, and y we're setting dot values, which is nothing but the mean price that we see here. Then we are setting the figure size. Again, you've seen all this in the previous video, so I'm just reiterating stuff. We're setting the figure size, we're setting the title of the plot, we're naming the x and the y axis here, we're setting the ticks, and finally we're generating the plot, and this is what we get. Perfect. Next, we look at the bar chart and we'll answer the question, what is the mean sales for each outlet size? When you think about it, it's actually a very intuitive and deep question. We can use plt.bar instead of plt.plot to create a bar chart using Matplotlib. So again, I'll just run this code and here we go. Takes a bit of code to get there, but it's actually pretty easy when you look at it. Again, we're using the .groupBy function on the outlet size. Remember, we are trying to answer what is the mean sales for each outlet size. And that's what this line generates for us. And here we are sorting the numbers by sales because that's essentially what we want, right? Medium, high outlet size, and small. And everything else you've already seen in the previous code block. Setting the title, we are naming the X and Y axis, we're setting the ticks, and we're finally plotting the bar chart and just ensuring that the three outlet sizes are represented in different colors: red, orange, and magenta. It's pretty interesting here that the smallest outlet size is generating the most mean sales. Actually, pretty interesting. Next, we look at the histogram and we look at the distribution of the item price. Histograms are actually very common types of plots when we're looking at univariate data like height and weight, stock prices, what is the waiting time for a customer, etc., which is basically continuous in nature. In Matplotlib, we can use plt.hist to draw a histogram. It provides a lot of parameters to customize and adjust the plot, which we've provided the link and you can explore it there. Let me just go ahead and run this code. And here we go. We can see the item MRP distribution. Very simple code. We're giving the title of the plot, what is the x-axis, what is the y-axis, and we're just simply plotting it here. Data underscore BM is of course our data frame. Item MRP is the column that we want. Color, of course, as you can see, is light blue, and bins underscore 20 is basically the range that we want here of each block, right? So this is 20, this is 20, this is 20, this is 20 on the x-axis. Next, let's explore box plots. Very interesting concept. And we'll look at the distribution of sales using these box plots. Recall what we studied in the statistics module. Box plot shows the three quartile values of the distribution along with extreme values. Really helps us to understand if there are any outliers in the data and what's basically the distribution of the data that we have. Box plots are also called as box and whiskers plots. So let's try to visualize the distribution of the outlet sales. So let me go ahead and run this. Perfect. So here red diamond is basically the shape of the data points that we want, and that you can see here. And you've named the title, and here we're passing dot values. We are saying labels, item sales, that you can see here, the x-axis label. And flyer props, red diamond, again as I mentioned, is the shape of the data points. Remember how to interpret box plots. This is the lower range, this is the upper range, this is the second quartile, this is the third quartile, and this is the median. So anything above that you can consider as an outlier based on the data that you have. We can actually create multiple box plots for different columns in our data set. It often happens in the industry that we want to explore two or more variables using box plots in one go. So instead of manually creating one after another, we can plot multiple box plots in the same frame using the subplots function that we saw earlier. So let's see item weight and item MRP distribution together. Again, using the same code except that we've added a new variable. And of course, using the subplots function as I mentioned. So let me run this, and perfect. We've generated two box plots in the same frame, a very valuable feature. Widen plots are actually very pretty to look at, and they tell us the estimated density of the underlying distribution. So here we're using the item weight and the item MRP variables again to generate the violin plots, and here we go. As I mentioned, you can see the density of the underlying distribution for both these variables. Very useful feature. Scatter plots. I'm sure you've heard of this or come across this plenty of times before. Scatter plots basically depict the distribution of two variables using a cloud of points, where each point represents an observation in the data set. Scatter plots allow us to infer a lot of information about whether there's any meaningful relationship between the variables that we're plotting. Just to note that we're using only a subset of the data for the plots here. We're only using 200 data points because then we can generate plots that make sense, right? If I use the entire data set, this entire plot will be filled with points and we won't be able to really understand intuitively how this works. So as you can see, these are all individual data points representing item visibility and item weight. And finally, we look at bubble plots. It's a very interesting concept and a lot like scatter plots, except that we can now understand the interdependent relations among three variables. That's right. Bubble plots let us analyze three variables in the same go. Again, we'll only use a subset of the data to truly understand how this works. I'll just run this. Here we go. Do you see what we've done here? where we have item MRP on the x-axis, item outlet sales on the y-axis, and I've set item visibility as the size of the data points. That's how we get three variables into one plot. And why size? Because the bigger the size, the more the item visibility. I've multiplied this by 1000 because the value of item visibility was pretty small in our data set, and compared to item MRP and item outlet sales, it would not have come out. That's why we multiplied it by 1000. But as you can see here, the bigger the bubble, I'll reiterate, the more the item visibility. That's how a bubble plot works. And that's essentially how all these plots can be generated using Matplotlib. Very interesting stuff, right? But you might have noticed it took quite a lot of code to generate plots, right? We needed 4-5 lines to generate simple plots. What if we could do this using just 1 or 2 lines of code? Generate equally impressive plots but with even less time and code. It is possible, and we'll see how in the next video. Let's turn our attention to another very popular data visualization library called Seaborn. Seaborn is actually built on top of Matplotlib and provides a high-level interface for generating attractive and informative statistical graphics. Seaborn provides choices for plot style and color defaults, defines simple high-level functions, very common plots that you see, and crucially integrates with the functionality provided by Pandas data frames. One of the best things about Seaborn that I personally like is that unlike Matplotlib, where we have to code multiple lines to generate plots, we can do this in just 1 or 2 lines using Seaborn, as you'll soon see in this video. So we'll cover the basic plot types using Seaborn in this video, and we'll look at advanced categorical plots and density plots in the next video. So let's get into it. We'll first import the required libraries. We're of course importing Seaborn as SNS, and we're setting the style as dark grid. That's basically the theme we want to use with Seaborn. You can look at the official Seaborn documentation to play around with themes and look at what other styles are available. We are also importing NumPy, Pandas, and of course the Matplotlib library. So I'm going to go ahead and run this. We'll be again working with the BigMart sales data. We're already very familiar with this. We just saw it in the previous video. So let me quickly just read it in. We'll remove the missing values, multiply item visibility by 100 just to increase the size of that column. Again, we saw this in the previous video, and we'll use the dot head function to look at the first 5 rows. And here we go. I won't delve into all the variables as we've already covered this and we know what this dataset is about. So let's get to creating basic plots straight away. First, we'll have a look at a line chart. We can generate a line chart using the dot line plot function in Seaborn. Are you seeing how incredibly easy it was to generate a line chart? Literally 1 line of code. What we want on the x-axis, which variable we want on the y-axis, and the name of the dataset. Of course, we're selecting only 50 rows here just to showcase how the line chart works and not the entire dataset. But just gives you an intuition as to how easy it was to generate a line chart. When I look at the Matplotlib line chart, this is the entire code that it took to generate 1 line chart. And we did this in 1 line. Incredible, right? Let's now look at a bar chart. Again, 1 line of code, and here we go. That is mind blowing. And just look at how good this chart is. We have different colors, we have a background grid, including lines, which align with the numbers on the y-axis. We also have the x-axis label, y-axis label. I mean, just so impressive. Let's draw up a histogram now. We can do this using the dot distplot function. And all we needed was to pass the column name. And here we have the histogram. Amazing. Let's check how we can generate a box plot. You can do that using the dot box plot function. Pass in the column name that you want to analyze and just put the orientation as vertical. So I'll run this and here we go. You've seen this in Matplotlib. You can see the outlier values here. And when I pull up the Matplotlib data, I'll just show it to you here. Again, it required this amount of code, which we did in 1 line. Just for your information, if I put this as horizontal, what do you think will happen? There you go. We get a horizontal alignment. It really is that simple. And now let's look at a violin plot. Again, using 1 line of code. Remember, a violin plot basically tells us about the estimated density of the underlying distribution. And we've done this for the item outlet sales variable. A beautiful chart. We didn't even need to code the what is on the y-axis, what is the range. It just intuitively generates such a wonderful plot. Now let's look at a scatter plot, one of the most common plots we generate in machine learning to analyze the relationship between two variables. So let me just plot this. We are doing this using the .rel plot function, and we're passing scatter in the kind argument. And this is the plot we get. Wonderful. Here we are analyzing the relationship between item MRP and item outlet sale. And you can see there is some kind of linear relationship here. Now here's a new concept called hue semantic. This allows us to add another dimension to the plot by coloring the points according to a third variable. That's right, we can introduce three variables and analyze their relationships using a hue semantic. So we'll use the .rel plot function and we'll put hue is equal to item type. Basically, the third variable which will color the points will be item type. So let me just generate it and you'll intuitively understand what this does. Did you see what happened here? We have item MRP and item outlet sales on the X and Y axis respectively. And these points are colored by item type, basically the third variable which you've introduced here. And Seaborn automatically generated the legend as well, without us having to input or code another extra line of code. Remember the line chart we created earlier? Well, we can create more complex line plots in Seaborn when we use hue semantic. So let me just generate a different line plot for different categories of the outlet size variable. Remember, outlet size was small, medium, and high. Just look at this line chart. When we increase the size, you'll be stunned at how much information this one simple line of code has packed in. Finally, we'll look at the bubble plot. Just as a reminder, I'll just open the bubble plot here. This was the bubble plot, remember? Basically, the bigger the bubble, the more the item visibility, right? And it took this amount of code to plot it. With Seaborn, it takes one line. Yep. We pass in the kind argument, we pass it as scatter. We select the size as visibility scaled and the hue as visibility scaled as well. Let me just generate the bubble plot. Perfect. Again, we've got a legend. How useful is that when we're looking at this plot? Perfect. We can actually create plots based on categories as well in Seaborn. So here we're creating scatter plots for each outlet size, small, medium, and large. So, and here we go. We have three different plots in one frame. So here we have item visibility on y-axis, item weight. So we're seeing the relationship between these two variables with outlet size as medium as the third variable. Here is similar with outlet size high and here outlet size small. How powerful that is. Analyzing three variables according to different categories in one frame. Such a useful function. And we did it again in just one line. In the next video, we'll dive into advanced categorical plots in Seaborn. It's another very interesting data visualization video and it'll really capture your attention. So I'll see you there. We now have an intuition of what Seaborn is and how incredibly useful it is to generate plots. Not only do we save time by writing just one or two lines of code to generate plots, the plots themselves are intuitively wonderful, neat, tidy, and just great to look at. In this video, we'll focus on advanced categorical plots in Seaborn and how we can generate them. So for categorical variables, we broadly have three different families in the Seaborn library. We have categorical scatter plots, categorical distribution plots, and categorical estimate plots. And the best part of all these is that we can generate all of them by using just the cat plot function. That's right. All we need to do is change the kind depending on what plot we are plotting. So for strip plot, its kind is equal to strip. For swarm plot, its kind is equal to swarm, and so on. It really is that easy. So let's look at each of these plots and see how we can generate them using Seaborn. First, we'll look at the categorical scatter plot, starting with the strip plot. Strip plot basically draws a scatter plot where one variable is categorical and the other is a continuous variable. Remember, we saw a scatter plot where both the variables were continuous and we saw the relationship between them. Strip plot basically gives us a relationship between a categorical variable and a continuous one. So let me just generate this and here we go. We use .catplot. We said we want the outlet size variable on the x-axis and the item outlet sales on the y-axis. Kind is equal to strip since we wanted a strip plot, and of course the data. And this is what we get. Outlet size medium, high and small. Wonderful plot. Second is the swarm plot. It's actually similar to strip plot, but the points are adjusted along the categorical axis so that they don't overlap. This gives us a better representation of the distribution of values. So let me just plot this and see. Here we go. So it's the same code except kind now we're using swarm for the swarm plot. You might be wondering what's the difference between this and the strip plot we saw. They both look incredibly similar. Well, in the strip plot, notice that the individual data points are overlapping into each other. A swarm plot does not always scale well to large numbers of observations. Just keep that in mind when you're using it. Next, let's look at categorical distribution plots, starting with box plot. Remember the code for box plot we saw in Matplotlib? Let me just pull that up for you. Here we go. It took us all of this code to generate this simple box plot, right? Now, what all I'm doing here is I'm passing kind is equal to box to the .catplot function. And here we have it. Incredible, right? Look at the difference. Here it's a very plain plot. You can't see the individual data points. And it took a lot of code to generate this. In Seaborn, it took just this to generate such a wonderfully illustrated box plot. I'm sure you can see why I appreciate Seaborn so much. Let's look at violin plots. Here we go. Kind is equal to violin, and we have again by category outlet size against the item outlet sales on the y-axis. And just for your reference, here's the violin plot with Matplotlib. Look at the amount of code in the output, and look at just one line of code in the output. See the difference? Let me just generate a bar plot here. Again, we'll pass kind is equal to bar here to the catplot function, and here we go. So again, I'll refer back to the bar chart we generated with Matplotlib. Look at the amount of code it took. And we did this with just one line by saying kind is equal to bar to the catplot function. That's it. Finally, let's look at density plots. These help us get a smooth estimate of the distribution using a kernel density estimation, which, just for your reference, Seaborn does with sns.kde plot. So let's see the distribution of the item visibility variable. Here you go. So all we did is .kde plot. We gave the variable name and we said shade is equal to true. What do you think shade is equal to true means? What if I remove this? What will happen then? Let's see. Interesting. The shaded area has gone. That's why shade is equal to true was used. So let me just put that back and generate. And as you can see, shade is equal to true generates the shaded area here. Perfect. Now let's look at the distribution of the item MRP variable. Again, shade is equal to true, and here we have the density plot for the item MRP variable. We can even combine histogram and density plot using the .displot function. Here you go. So you can see the outline, that's the density plot, and we can see the different bins as well using the histogram. Such an intuitively informative plot. And then there are pair plots. What do pair plots do? It's actually very interesting. Pair plots are very useful for exploring correlations between multi-dimensional data when you'd like to plot all pairs of values against each other. I'm going to use the iris dataset here. I'm sure all of you must have heard of this and actually used it before. So I'll just load it and show you the first 5 rows of the dataset. So it's basically about different plant species, and there's sepal length, sepal width, petal length, and petal width. Visualizing multi-dimensional relationships among the samples is as easy as calling sns.pairplot. We're passing the dataset name, setting U as species, and just the height of the plot. So let's just generate this. We'll just give it a second because there are a lot of plots that will be generated now. And here you go. Look at this. What a beautiful plot. So just want to call out a few things here. The diagonal length that you see here, all these plots across the diagonal, these are univariate data. Basically, they're analyzing one variable. So we have this density plot for sepal length, this density plot for sepal width, and so on. And the other scatter plots that we're seeing are on bivariate data. Basically, they're analyzing the relationship between one variable on the y-axis and the other on the x-axis. So let's take this. So this is the relationship between sepal length and petal length. That's how pair plots work. And of course, we have the legend here as well, signifying which color belongs to which kind of species. Seaborn is truly a very impressive library, and I encourage you, in fact, I strongly recommend you try it out, experiment with it, and use it the next time you're exploring the dataset that you have in hand. You'll truly appreciate the power of Seaborn then. Let's understand what regular expressions are and how we can leverage them for text feature engineering. Simply put, regular expressions or regex is a sequence of characters mainly used to find or replace patterns embedded in the text. Let's take an example to get some intuition about regular expressions. I have a list of names of my friends Sunil, Sumit, Ankit, Surjit, and Surbhi. If we were to select only those names from this list which matched a certain pattern, so say the first two letters are S and U, followed by only three positions that can be taken up by any letter. What do you think? Which names fit this criteria? Let's go one by one. The names Sunil and Sumit fit this criteria as they have S and U in the beginning and three more letters after that. But the rest of the three names are not following the given criteria. One is starting with A, whereas the others have more than three characters post S and U. So what we have done here is we have a pattern or criteria and a list of names. And we're trying to find the names which match the given pattern. That's exactly how regular expressions work. In regular expressions, we have different types of patterns to recognize different strings or characters. Let's understand about these terms in a bit more detail. One key aspect about these patterns is that they represent a textual meaning. For example, /d is a regular expression pattern which indicates numbers present in the text. As you can see here, the highlighted numbers in this text can be extracted from this regex pattern. But that's not all. Using regular expressions, we can build rule-based information mining systems. This is not the only pattern. There are many more patterns to extract different kinds of information. Feel free to check out the resources below this video to learn more about regular expressions. In the next video, we will jump into the Jupyter Notebook and get a hands-on experience of working with regex. I'll see you there. Got an introduction to regular expressions in the previous video. So now let's see how they work in Python. The first thing I want to start off with is the concept of a raw string. Python raw string treats backslash as a literal character. Let's see some examples to understand this. As you can see in this code block, we have a couple of backslashes. Now Python treats backslash n as move to a new line. Let me print this out and you'll see what I mean. Here, as you can see, backslash n has moved this path to a new line. So Nathan has become Ethan here and backslash n has disappeared from the path. That's not what we want. So here we use our expression to create a raw string. So I'll print out this code block. And as you can see, we have the entire path that's been printed out here by simply using R here in front of the path. Perfect. So it's always recommended that you use raw strings when you're dealing with regular expressions. Python actually has a built-in module to work with regular expressions called RE. Some of the most commonly used methods from this RE module are re.match, re.search, and re.findAll. So let's look at each method with the help of a simple example. The re.match function returns a match object on success and none on failure. So here we'll first import re and we'll use two variables and use the re.match function. Here analytics is the pattern which we'll use and this is the text that we have. And notice how I've used R here, which we discussed earlier. Alright, so let's print this out and let's see what we get. Alright, so what do you think is the output here? Here analytics is the pattern which is present at the beginning of this text. That's why we get a match here. And when we are using largest as the pattern, it's not present at the beginning. That's why we get none as the output, which again we discussed here. Now, since the output of the re.match function is an object, we'll use the group function to get matched expression. So let me just print this out, and here we go. Analytics was the matched function that we saw here. Perfect. Let's jump over to the re.search function, which matches the single occurrence of a pattern in the entire string. Notice that I'm saying entire string and not the beginning of the string here. So here, as you can see, we have the re.search function. We'll use founded as the pattern, and this is the text that we have. So let me run this code. Alright, perfect. The re.search function has matched the single occurrence of founded in this string. The third function is re.findAll. It returns all the occurrences of the pattern from the string. So again, we'll use the same sentence, founded as the pattern and this as the text, and print out the result. And since we have founded twice here and here as well, that's why it's been printed out twice. I would recommend using re.findAll as much as you can, because it works like both re.search as well as the re.match function. Now we're going to look at some special sequences that come up with regular expressions. These are used to extract different kinds of information from a given text. Let's spend some time understanding how these special sequences work in Python. The first is \b, which returns a match where the specified pattern is at the end of a word. So as you can see in this code block, we'll use the same string we saw earlier, and we'll use the re.findAll function. We'll use ICS as the pattern, and we'll use a special sequence \bl. Let me just print this out. And as you can see here, we have two patterns that have come out. ICS, which is at the end of analytics here as well as here. So let me use another pattern as input. Let's say we use EST, and let's see what we get. Alright, we have one instance, one pattern, which is at the end of largest. So that's how \b works. Second is \d, which returns a match when the string contains digits, basically numbers from 0 to 9. So this is the string we're going to use, 2 million monthly visits in Jan 19. So we'll use the re.findAll function. We'll use, again, as I mentioned, \d as a special sequence, and str is a string which we mentioned here. Let me print this out. Perfect. 2, 1 and 9, as you can see here, are the digits that have been generated from this function. But is that what we want? Because 19 here is together and we have 1 and 9 as separate output here. Let's see how we can combine it together. All we have to do is use the plus sign in front of the \d. That's all we need to do. And here, as you can see, we get 19 together. Perfect. Let's look at the third special sequence. \d, which returns a match when the string does not contain any digit. Basically in contrast to the \d we saw earlier. So again, we'll use the same string, and we are inputting \d here, and let me print this out. Perfect. We've got all the strings where there are no digits. But similar to \d, we're getting individual strings here. Let's put this together again. We're getting individual characters here. So how do I get the combined characters like we're seeing in this string? I'm simply going to use plus again to get this. And as you can see, we have million monthly visits here. 2 and 19 has been removed by the \d function. Perfect. The fourth special sequence is \w, which helps in extraction of alphanumeric characters only. What are alphanumeric characters? These are characters from E to Z, digits from 0 to 9, and the underscore character. So again, using the same string, I'll just print this out, and again, these are the alphanumeric characters that we are getting. Perfect. And similar to what we've seen earlier, we want all of these to come together, like in these words, right? So again, we'll use the plus function. That's all we need to do. And we have the alphanumeric characters that make much more sense now. The final special sequence we'll see is, you guessed it, \W, which returns a match at every non-alphanumeric character. So I'm going to go ahead and run this. You're very familiar with this notation by now. Perfect. We have every non-alphanumeric character. We have an empty space. We have an exclamation mark. Perfect. Now let's look at some meta characters that are used in regular expressions. Meta characters are characters with a special meaning. If you're wondering what that means, don't worry, we are about to find out. The first meta character we look at is a dot. It basically matches any character. So we're going to use this string. Rohan and Rohit recently published a research paper. So what dot will do is it'll search for a string that starts with RO, as we are mentioning here, followed by a certain number of characters. Now, how many characters should it search for? Well, that will depend on the number of dots that we are giving. Let me print out this code block and we'll see. Here we go. Since we only gave one dot here, that's why we've only got one character in the first in X. In X2, we've given 3 dots. That's why we have Rohan and Rohit as the output. In the second meta character, we look at the caret. So let's see what that is. We'll use a simple data signs as a string here, and we'll put data as the pattern after the caret meta character. Let's see what that does. Alright, so what caret has done is it's checked if the string started with the data, the pattern that we gave. So if I put signs here, let's see what happens. It says no match because our string started with data and not with signs. That's how the caret meta character works. Let's try with another different string. We have big data as a string here, and we're using data as the pattern. Let me print this. Again, there's no match because the string is starting with big, and we'll just verify that by using big here. And yes, as you can see, the output is the string does start with data. Perfect. The third meta character is the dollar sign, which checks if the string ends with a given pattern. So let's print this code block and we get no match because we used with as the pattern here. Now, if I use signs here, I get yes, the string ends with signs. What do you think will happen if I use data as the pattern? Will we get a match or not? We don't, because the dollar sign checks if the string ends with signs, not with data. The fourth meta character is the asterisk. It matches for 0 or more occurrences of the pattern to the left of the asterisk. So here's the string we're going to be working with, and this is the pattern we're looking for. Basically check if the string contains EA followed by 0 or more S characters and ending with Y. Let me print out this code block and see what the result is. Okay, so we have these three strings. Interestingly, we don't have EY in the output. Why do you think that is? Because EY does not contain the pattern that we're looking for. There's no EA here. The fifth meta character is plus, which matches 1 or more occurrences of the pattern to the left of plus. Just want to highlight here that asterisk was 0 or more occurrences, plus matches 1 or more. It's very important to understand this. So we'll use the same string, and again we'll check if the string contains EA followed by 1 or more S characters and ends with Y. So we'll print this out, and again this time we get these first two strings. We don't get EAY and EY. Why? Because EAY does not contain any instance of the S character, and EY we already established before. That's why only EASY and this string have been given as output. The next meta character is the question mark, which matches 0 or 1. Emphasis 0 or 1 occurrence of the pattern to the left of the meta character. And again, we'll search if the string contains EA followed by 0 or 1 occurrence of the S character and ends with Y. So let me print this out. And interestingly, this time we get EZ and EAY in the output. We don't get this. Why do you think that happened? Because remember, the question mark meta character is matching 0 or 1 occurrence of the pattern, and S is occurring multiple times here. That's why it's not being generated in the output. And the final meta character we look at is the pipe operator, which is basically the either or operator. So we look at a different string now. We'll use Analytics Vidya is the largest data science community of India. We'll use the pipe operator here to check if the string contains either data or India. And of course there is one match because both of those words are present here. Let's try with a different string. Now we'll use this string and check again if the string contains either data or India. So let me print this out. There is a match, but we are only getting data here and not India because it's not present in the string. Let's spend some time understanding sets and how they work with regular expressions. A set is a bunch of characters inside a pair of square brackets. Let's look at a few examples. We're going to work with this string again. Analytics Vidya is the largest data science community of India. Now we're going to check for the characters Y, D or H in this string, and we'll put that between these square brackets. Let's see what we get as an output. Perfect. We have every occurrence of these three characters in this string as an output. Now let's check for the characters between A and G, basically the range A to G in this string again. Again, I've put that between the square brackets here, and we'll run this code. Here we go. So we have all the characters between A and G in this string here. Perfect. Now let's solve a problem. Let's take another string, a very interesting one. Mars's average distance from the Sun is roughly 230 million kilometers and its orbital period is 687 Earth days. What we'll do is we'll extract the numbers starting with 0 to 4 from the above string. So we've put that range between the square brackets. And remember what \d plus did? It searches for digits in the string. So let's print this out. Yes, there is a match. You can see 230 has been printed out. And since 230 has numbers between 0 and 4, that's why it's the output. If I change this range to say 5 to 9, we get 687. As you can see in this string, we don't get 230 because we changed the range here. It's really that simple. Now we'll use the caret meta character to check whether a string has other characters mentioned after the caret. So we'll check if every word character has characters other than Y, D or H in this string. So let's run this, and here we go. We have the output is basically every character other than Y, D or H in this string. And finally, we'll check whether the string has terms starting with characters other than alphanumeric. Recall what the alphanumeric special sequence was. It was \w plus. So we'll run this code. As you can see here, we have @AV and #AV. Basically, all the words that start with a special character have been extracted from this string. Now let's solve some complex queries. This is going to be a lot of fun. Let's try to extract some email IDs from this given string. Here we'll use the re.findAll function. So let's understand what's going on here. We are basically taking a range here, A to Z, capital A to Z, 0 to 9, dot and underscore, as well as dash, and putting this in the square brackets, basically the sets that we saw earlier. This will be followed by @alphanumeric character, which will be further be followed by .com. Basically what an email address typically looks like. So I'm going to go ahead and run this. Perfect. As you can see, we've extracted the 3 email IDs that we had in the string. And also notice that these email IDs have differing types of notations. This is Rohan.1997, Smith underscore David 34, Priya@Yahoo. So different types of email IDs, but they've all been extracted using just one line of code. Regular expressions is truly awesome. Next, we'll extract some dates. Here's the string we'll use. Here we're using \d. Remember, this is for searching for digits in the string. And 4, 2 and 2 here is essentially looking for the format that you see here in the string. So I'll go ahead and print this out. And you can see that both the dates have been extracted from the text. Perfect. Now what if there was a slightly different date format? Instead of 07 and 08, we have JUL and AUG for the month. Here, all we do is we change the range. We use 2, 3 and 4 instead of 4, 2 and 2. And you'll see the difference. Again, we've been successfully be able to extract the date. But what if there were dates of varying lengths? I'm sure you were wondering this. Here we have 27 July 2012 and 12 August 2012. July is 4, August is 7. There's 2 varying lengths. What do we do here? It's actually pretty simple. Simply put a range 3 and 10 here. So basically it will search for any length between 3 and 10. So let me print this out, and as you can see, we've been successfully able to extract. Even if I put September here instead of July, because we've put the length range here, it is able to pick that up perfectly. Now, let's work on a data set, the Titanic data set that you're all too familiar with by this point. We're going to use the names column and extract the titles from them. So first we'll import the pandas library and load the dataset. Let's look at the first 5 rows using the dot head function, and you're very familiar with this. We're going to be working on the name column for this video. So let's print the first 10 names here. Okay, here we go. Now one way to extract the title is to split on the pandas data frame and then extract it. So here I'm going to use this name Alan Mr. William Henry and split it on the dot. Now we have two texts Alan, Mr. and William Henry because we use dot as the split function. We use dot to split the text. Alright. Now we'll further split this using commas. Let me do that. And here we go. Perfect. Okay, so what we've done so far is for just one name. Now we'll use this across the entire name column and see how it works out. Nice. So we have the value count for each title. Mr. is an overwhelming occurrence in a dataset, 517 times, followed by Miss, Mrs., Master, and so on. But this method might not work all the time. Therefore, another more robust way is to define a pattern and search for it using regular expressions. So let's go ahead and do that. We'll first define a function, split underscore it, which will basically return any alphanumeric character. Okay, let's do that and print it out. Perfect. How quickly that worked. So we extracted the titles from the name column along with their value counts. So this was all about regular expressions. Quite a comprehensive thing we've covered. Thank you.